Hey guys, welcome to the first 3 episodes of a full commercial project series in Revit MEP Electrical. It includes power plans for the parking level and the first 2 levels of the 5-story Snowden Towers project. So if you're wanting to learn some commercial Revit electrical techniques, follow along with this step-by-step project. This is episode 1 of a brand new series on a commercial electrical design starting from scratch. We're going to use the 5-story Snowden Towers example architectural project from Autodesk, and we're going to create an electrical design from the ground up using many custom symbols, custom families, custom panels, and I'll show you links to videos on how to create all of that custom content so that you can have a professional looking and professionally connected project, including all of the equipment like elevators and getting solar ready to the roof and EV charging points and all the lighting, all the power, and getting service equipment and panel boards and meter centers, most everything you can think of for a multifamily and mixed use kind of project. So stay tuned for this episode and all of the rest. It's going to be a bumpy ride. Let's get right into it. So the first thing we're going to do is get an architectural Revit model that we can use as a background for our electrical design. So what we're going to use is an out-of-the-box Autodesk sample project. And if you just go up and search engine your Autodesk sample 2024 Revit sample projects down here, try that. And in this, you will see this one project under 2024 called Snowden Towers. And this has all of the trades in it, even has an electrical. Now, because we're going to start electrical from scratch, we don't need it. You could download it and take a look at it and see how that consultant designed it. We're going to design it a little bit differently because each area of the country, of course, each country, and then even different firms have different ways of presenting their plans. So we'll do it with our methods. And so let's just bring in the architectural itself. So if you click on architectural, it will download up here, and then you can open that up. So let's go into Revit and get this opened up. And if we go into Revit 24, we can open that up. In my ER folder, I have it under an XREF. That's our old CAD naming, but we also use it for linking in architectural files. So here's the Snowden Towers sample architectural right here. Let's open that up. Now this is a more advanced project. It has 5 levels and a parking level. So it's a good sized project, but it will show a lot of techniques that you can use to design and document your own project. So here it is. And they've given a rendering of the front of it, and it includes these 3 tower areas, modern, and then they also have an old-fashioned facade in front of that. So what I like to do first is to examine the architectural model to learn some things about this project and some specific Revit things like levels and how they've divided up views and what scale are they doing things in, even how do they name their sheets. So you can start here by going through the sheets. I also create a PDF set. I export PDF or print to PDF a set of these for reference during my electrical design. Because when we link in this model, the link isn't always enough to show you what you need. You won't see notes, things like that. So let's take a look at this. They have the G drawings, which is the cover. And then they have, of course, some learning aspects because this is a sample project. They have parking deck, and then they have life safety plans. And if you're familiar with commercial design, you'll notice that architects have these life safety plans to show exiting from the various rooms and buildings and how far that exiting path is. Green line, it's almost 50 feet, it takes 11 seconds to get out. And this will give you an idea, if you're doing lighting design at all, where exit signs may need to be placed, what is a path of egress, things like that. Maybe somebody else is doing lighting design and you don't need to worry about that aspect of it, but that's what these life safety plans are for. So let's get into the actual floor plans. A100 is the parking deck. And this is the architectural floor plan for the parking deck floor plan. And they have a graphical scale. They're laying theirs out an 1/8 inch, which is very common scale. shows the north arrow. So true north is a little bit off to the right. This would be set up as project north so that the plan is horizontal vertical. We've got grids 1 through 9. It has a diagonal on this side. We have a number of parking spaces. Here's the drives in and out. We have an elevator E1 with its machine room, some stairways, 3 stair towers. We have another elevator, E2, elevator 2, and its machine room, and then some storage behind that. And then down here, this is probably some storage. And we have this utility space, which will become our electrical room. Main electrical room will be down here in the basement or parking level 1. And this brings up a good point where let's take a look at what levels do we have in this building. So we're still here in sheets, but we can look at building elevations to get a good idea of the actual levels and furthermore floors in this building. So for example, if we look at this, our building starts here and goes to the left, clear down to here. Now, they don't have grid lines on this view, but what we can see is that it looks like a sloped floor. The street or grade slopes up. So these doors are a little lower than those doors, which are a little lower than those doors. So we have a stair-stepped floor. And then these are even lower. So we'll have to deal with that. And what you can see over here is we have the parking level, and then we have level 1, block 35, another level 1 at block 43, which is their 00. And there's an interstitial level in here too, which they don't show on this view. We have an M1, which ends up being a mezzanine. So there's some things on a mezzanine level. And then we get to level 2, which would be floor 2, second floor. L3 will be third floor. L4 and then 5 are the fifth floor. And then we get to what they're calling a roof 1. So part of the building is on roof 1. And there's another roof 2, parapet, and roof 3 and another parapet. So you can see that this is a complex building with multiple levels, stair-stepped floors, stair-stepped roofs. So everything you can run into on a project, which is a good complex project to learn some techniques. And, real life projects sometimes end up being like this. So it's good to have these tools in your belt. And this is just the north view, not the front view, the back view, which ends up being the north elevation. And it's just windows and balconies. Some of the other elevations will probably be east and west. And this is an elevation of just the isolated front with this very decorative old look. And up top, you can see there's some kind of a trellis thing up here. But again, all of these different levels that we will have to take a look at. And then they do building sections as well. So we can see how things look if you cut the building in half longitudinally. And we can see we have a cafe down here. But let's keep looking at these floor plans. Now that we know the levels, we already saw the parking level. Let's look at the first floor plan, which had, 2 or 3 different levels itself. Now they have it all on one sheet, one plan. We have here from left to right, our elevator. It's a cafe kitchen. So a small kitchen in here and a small cafe with its restrooms. The stairs. And then we have a commercial/retail, most likely a tenant space. And it's not fully fitted out. So this is probably just a empty shell for a future tenant, for a future TI, tenant improvement. And then we have the residential lobby with a revolving door and regular man doors. And it goes upstairs here. And this goes up a couple steps to another level to the elevator. And then in the back, we have some utility space with the trash chute. So that's what's going on there. And then here we have another storefront with a commercial retail space with a couple steps. That's a large tenant space with its own restrooms. And then we have another commercial retail tenant space with this entrance and restrooms and some utility areas. So we've got like 3 retail tenants. We've got residential in the middle. We've got the cafe on the left. That's level 1. Second floor, we have this mezzanine dining area. and this is open to below. Go up the stairs to the mezzanine for the cafe and the dining. And then over here, we have a live work unit, so a residential / commercial unit, a studio, a 2-story studio, another live work unit. This is open to below, that's the residential entrance. And then this must be open to below as well with the X. And this is also open to below. So these commercial spaces are rather high. They go up past the 2nd floor. Now, 3rd floor plan, again, we're just getting our bearings so we know what we're working with here. On the left, we get the office unit, so maybe an office tenant, another TI, and it has the unique slanted modernized front. There's an elevator serving that portion. And then we have more studios. Here's the top of this 2-story studio that had a spiral staircase up to it. Another live work unit. This is open to below. A live work, live work, live work, and live work. So a number of live work units that all have, looks like little kitchens or kitchenettes in them and their own restrooms. So we have a lot of equipment there. 4th floor. We have another floor of office tenant studios and this more 2 stories and live works. So a lot of residential up here above those retail tenants. Another office unit, studios, so very similar. Now we're up here, we have a green roof to deal with on level 5. A private patio out here for this live work unit. And then we have a green roof level, and it actually has some color on here. So this is showing what it's made out of. We've got decking and tiles and turf, but this is one of the roofs. And this looks to be seating area with stairs. So maybe some kind of a viewing outdoor area with that trellis thing here. And then another roof plan. And that may include the roofs of some of these taller little buildings above the stairs, stair tower, and elevator overruns. And then we get our ceiling plans. Now I notice we don't have a parking deck ceiling plan. They jump right into the 1st floor, so that's an issue. I should say that they're stating that this project is partway through design, so it's not 100% done, ready for construction. And you can tell because the architect hasn't said anything about these lights. Now, these are symbols for lights, but they haven't called out what they are. And maybe this job has an interior designer that's doing the lighting, and it would be on their plans. We don't have access to those, so we will have to investigate the model and figure out what's going on with those lights. But they show the lighting, they show the ceiling types on here, and 2nd floor ceiling. So we can go up and take a look at all these ceilings. And we're going to be bringing this into our electrical model, so we'll have access to all these locations. Take a look in 3D to see what this building looks like. It'll give us a good lay of the land. Now, 3D views can take a while to generate. So that took a couple minutes to generate, actually. But this gives us an idea. Here again is some pictures, some 3D renderings of the building itself. There's the back of it. Interior renderings, so you can see some of the staircases. So this is like a 3-story entrance. Nice big area. Here's some of the other areas. You can see they're open for future tenants. They even have some of the structure in here. We do have a structural model that we can bring into this. And another thing I'll bring up is we have the mechanical, HVAC, and plumbing models to bring in as well. So we will bring those in eventually for coordination purposes, so we can show how we can coordinate with those other trades with our electrical system. And some of the cafe areas. So this kind of gives an idea of what it looks like. We have a good idea what this is, but I want to show you some now the Revit details of this. We need to get into the nitty-gritty of how this is put together by the architect to help us decide how we will put it together and deal with it in our model. So if we go down to the actual floor plans themselves, the floor plan views, not the sheets. So we go to parking, and this is where we can actually get to all the pieces. You click on things and you'll see that it's a parking space, and these are just some lines and some annotations. But we can see that this parking level is created on associated level is parking. And then if we go to level 1, we know we have 3 level 1s. So this is going to be the tricky one. What level is this view created on? It's created on level 1, block 35. Now back when we looked at the section, 35 was the lowest level down here. And you can kind of just click somewhere. And what I'm done is I've clicked on a floor. And if I click on a floor over here, do it again, click on the floor. There, we highlighted it. We're on the floor. It is on level 1, block 35. The cafe floor is also level 1, block 35. Now let's keep going to the east here. This floor is on level 1, block 37. So it's at a different level. It is actually hosted to block 37. Keep going to the right. We have block 37, 0. And then we have this, which is block 37, but it's 1 foot offset from block 37. So it's 1 foot higher, and that's why we have the couple down steps to get to actual block 37. So we have a number of different levels to deal with. Even just within that one level, block 37, we have multiple levels in here. And in the back, block 37 at 0. What is this one? Block 37 at 0 and block 37 at 2 feet. So this level is 2 feet higher. And the reason I bring this up is if you want your receptacles, for example, in this space to actually be at the proper level in 3D, we will have to make those adjustments. And also it will matter how we assemble, how we create our views and working views, coordination views, to make it easier to install receptacles and other devices, light switches and such in here relative to these different levels. And then finally, this guy is at level 1, block 43. So we have block 35, block 35, block 37, and block 43. Like I say, when they put these things in, because of these different levels, if you set this whole plan up to block 35, the architect wanted to install a wall. They want the wall to go to block 37. Well, you would have to manually go in and say, extend it to block 37. Well, what they've done is if we go down and look at what they're calling their floor plan working views, this is a good example of you have production views, sheet views that get dragged onto a sheet for like a finished product. But then you also have other views which are just used to assemble this model, to create this model, and they won't get dragged onto a sheet. They're just for working in a more convenient layout. So for example, we have rooms for L1 block 35. They've got one for L1 block 37 and for L1 block 43 for the 3 different levels. This one happens to be rooms. So for example here, this area here is set up to block 37 is the associated level, and they've narrowed in the crop, so it's only dealing with certain areas. So we can take a hint from this. When we're creating our model, we may want to have some areas that are set up to the different levels. However, we may want to present them all on one floor. So you can see that they've split things up so that this can be on block 43. So that's one thing you can do, is have different views. But in the final view, to make things look properly, you may need to do plan regions in some areas. I have a video that explains view range and the plan regions, which are areas that can have a different view range than the default view range. So the view range, which deals with the vertical aspect of this, the bottom level is this associated level, which is the lowest, level 35, block 35. The cut plane, and I cover that in that video, but in short, the bottom of it, the cut plane is where it's cutting the walls so we can see furniture, walls, stairs at a certain level. And then we have the top up here, which is the top boundary, is at 7.6. So that's the standard view range. However, to see what's going on in these other areas that have different floor levels, they've had to create a plan region. So let's see if we can find a plan region in here. They are hard to find because they're a tiny little dashed line. One trick I use is I can go over here to this view template and bump up the size of the plan region line work so that it pops out. It's an annotative element. But if I go down to plan region, they are turned off. So let's get those turned on. And I'm also going to make the line weight something like 10 so we can really see them. There they are. See these green lines? That one there is a plan region. And its information, let's click on it again. There. It has a separate view range. Now its view range is based on block 43, which is this high level. So this separate area is set up with block 43 in mind, bottom, and then the middle is 4 feet above that, and the top 7.6 of block 43. So that block 43 looks proper. Now this center portion, this one, and they overlap. So there we go. This one is set up for block 37, the middle block, 0, 4, and 7.6 for its dimensions. Now, one thing you may notice is there's a little bit of a odd pattern down here, and we'll get to that in a minute. But the furthermost left one doesn't have a plan region around it because it by default is the level 35. So this is the default level. The other two have their own plan regions because they're set up as different levels. Now this center portion here, in here we have another little plan region. And what's that? That is set up with block 37, the middle region. However, the cut plane's high at 9 and the top goes clear up to 25 feet. Now, my hunch is they've done that so that they can see most of this stairway. Because if we don't have the plan region, let me move this plan region. Let me change it so that we can't see the plan region, just to see what happens. Move the boundaries. If we don't have this separate plan region with a higher cut line, and it takes a minute, see what happens. The slash for the stairs is way down low, and so we wouldn't see the stairway. So what they've done, let me undo this. What they've done is created a plan region so they can see the stairway better. So they've created a different plan region. But that's how you can control the view range of different areas of your plan, because it's based on a default level that you have to set the plan up to as level, and then you can adjust it. So we can use these same techniques on our plan to make things show up properly. And again, if they hadn't used this plan region, let me get rid of this plan region as a sample. What happens to this last block? You can see, because it's set up for the lower floor plan, our cut line does not cut through the stuff that's on this floor. So undo it. Now we've created a plan region so we can see the walls of the restroom and all that. So again, that's what plan region's for. And if you're getting anything out of this video, I'd sure appreciate you hit that thumbs up like button. And also, if you want to see more of this and see the rest of this series, hit that subscribe button. I really appreciate it. Drop me a comment. Let me know what your experience has been in your Revit electrical journey. And let me know if you have any questions or concerns, and I'd be glad to help. And then level 2 and on up are very straightforward because they follow a full level, except for this mezzanine. So we have that M level. This mezzanine floor is set up for the M1 level. However, this whole sheet, this whole view is set up with level 2. So again, we have one little area, and here it is. Here's the plan region just for this area, and it is set up for level 2 with an offset. They also could have set this up for the M1 level, but either case, they've set up a different view range for this mezzanine area. And then we also see some more plan regions right here. There's a little one here that was set up. They've decided to set this up differently, referencing different levels. Maybe they wanted to show this window detail that's up high that you wouldn't normally see on a normal cut. Same thing here at this residential area. They wanted to see this staircase differently with a different range, and this facade, they wanted to have a different range. So you can have different plan regions to show different cut planes, different heights, and things like that to show it the way you want. And we may not need to do this for our purposes if we don't have any electrical, but if we want the architectural look right, we may have to come back and do what they've done. So you can see, analyzing the architectural model gives you some of the Revit clues that you wouldn't normally see when you bring this in as a link to your electrical model. And we'll do a quick finish review of this, and then we can get into our electricals. This one has no plan regions, so we're getting simpler now. What happens when we get to level 5? Same thing, that all works. Even the roof works with level 5. It happens to be the roof of the level 4 there. Now we have roof 2. We never did use roof 1. So roof 2 is a good level to use. And then roof 3, and I don't see any plan regions here. And then roof 3 is a good level to use as well. So that gives us good clues as to what levels we want to use. And you may want to take a note of this or just memorize it, that we're using roof 2 and 3. And the last thing I like to do is look at their title block. So go back to our first floor plan. We want to make sure that we have this title block available for our project. So what I will do is I can edit the family and save it, or I can click on this and I see it's E1 3042 horizontal Snowden. I can go down and find their title block under families, annotation symbols. And again, this was called, in this version of Revit, we can actually right click it and say, find in project browser. That's a handy button. So there, it opened it up for us over on the left. That's helpful. And what we can do is right click and just save it from here. And then we will save it into most likely our reference folder. And I just save it with one backup, save it. Now we have it available to bring into our electrical model that we are going to create. So we can close out of this model. We don't need to save it. And we're going to start a new electrical project. So new, depending on which Revit version you're in, you'll find different templates. Some will have an electrical only template, some will have an MEP, systems, and so you'll have different ones. So what we can do is browse their folder, and in this version, we do have an electrical default template we can use. Now I'm going to use the electrical template that I customized in that video. So I'm going to go find that. That's here in my ER folder, ER electrical template. And it's based on Revit 2022, but I can use it for anything 22 and above. I'm in 24, so that works. And let's open that. And say, yes, okay, we're creating a new project, not a template. And it will convert it. Just a quick review. Templates are typically created for the oldest version of Revit that you anticipate using for projects. Now, as a consultant working for others, we work for architects typically. We have to follow suit with whatever version of Revit they are using. So if they're still on Revit 2022, we have to be prepared to set up our model that way. So that's why 22 through 25, right now we're using our 2022 version. Our office standard is to have a template for every other year, the even years. So we will be creating a 2024 as well. But frankly, right now we haven't done many projects in 2024. So here we go. This is our starting view we had. And it was just a simple text starting view. The first thing we do is go into a floor plan so that we can bring in the architectural model as a link. So we'll go into first floor power plan. And there we are. And it is cropped. So right now we can uncrop it. And let's go ahead and bring in that architectural model. So we want to insert, link a Revit, and let's find that Snowden Tower sample architectural right there. Now, Take a look before you hit OK. Don't just say open. We want to go down. We want to make sure we bring it in properly. Now, there's a number of positionings you can have: internal origin to origin, center to center, shared coordinates, project base points, manual. What I would recommend is try to go project base point to project base point. That will get you at least lined up horizontally and vertically. The architectural will come in matching your project base point. And then we're going to acquire some coordinates from that architectural model to further refine. But we want to be the same project base point. And that may take a second to load in. It's a good size model. That architectural file has a number of links in it. It has all of the other trades linked in, and we're not going to see those because they are linked in as overlay, which is okay. We just need the architectural. So here is our architectural model. It comes in. Now what I would like to do when this comes in is lock it in place so I can't move it around. So I'm going to pin it. The next thing I like to do is to bring in its project information, which may have further information on its coordinate system. It'll have the project title, things like that we need for our title block. So let's go up to Manage, Transfer Project Standards. And this is where we're going to find a number of standards we can bring in from that project, but all we need is one. So let's check none. All we need is the project info. So down here under project info, check that, say OK. And it's going to bring in energy settings, location data, which is important. We want to match their location data, the project information, like the name of the project, and then some site information. And we want to overwrite ours. So there, we've done that. And the other thing we want to do is under coordinates, we want to acquire coordinates from our linked model. So we want the architectural model to have the master coordinates that we want. So acquire coordinates and click on the model. Coordinates are not acquired because the selected link has the same coordinates as us. So we're already good. We already match. We just want to make sure. So now we're all matched with location. And then the next step that I like to do is get this saved right away and get it named the way we want to. So file, we will save it as, it's a project. Get it saved as, I'm putting it in my ER directory, and I'm going to call this ER Snowden Towers. And I want to get electrical in here, and I want to know what version this is. R24. Now we have that saved. We're good to go. Now, if you're in a multi-person firm or department that you will have multiple people working on this project, you may want to now set it up for work sharing so that multiple people can be in this model at once. And you would do that in the Collaborate tab, and you would go to Collaborate and do all that. I show that in some of my other videos, how to set up work sharing. That also allows you to use work sets. In this project, I'm going to go without work sharing to show you that you don't need work sets to control visibility. In fact, I recommend that you don't use work sets for visibility. We're going to use filters instead, so we'll get into that later. But for now, we're not going to work share this. We're going to treat this like you're a one-person shop. It's just you working on this alone. The next step I like to do is to get my levels that I need brought in or adjusted for this project. Now, what you can see in my template, again, you can refer back to that video, is I have set up 5 floors, which means I have 5 levels in my project already set up. So I don't have to add those and create views. I've already got views created in my template, which saves me a lot of time. But I need to adjust the levels to match the architectural levels. We saw there was a number of different levels. So what you can do is go to an elevation or a section. I don't have a section created yet, so we'll go to a south elevation and look at the south elevation of this project. Now what we see is these guys in blue are my levels in my project, and then these other ones in black are the architect's project. And we can see some of the levels in here, and they're kind of scattered around, hard to find. So that is always a trick, is just trying to find where these levels are so that we can match them. And depending on how these have been dragged left and right can determine what you see in different views. Let's go back to our floor plan view, first floor power. And we're going to create our own section in hopes that we can see all of these levels. So up here, the section tool, I'm going to drag left to right and just create my own section. And if I double click on the head of the section up here, this arrow, now I see a section and escape out of that. Now I can see all my levels. My parking level, 35, 43, 37's in there. Now I can move these levels to match theirs. I need to find my levels. There they are. And I like to separate them so I can tell mine from theirs. So what I'm going to do is I'm going to make level 1 match this lowest block 35. I'm going to need to add a level for parking. And I'm going to need to add some other levels for these others. So let's move this guy, and I'm just going to align it to this level. So I go to there, and then from here, and it aligns it. And so that's level 1, and I'm going to do what they did and call it L1 block 35. Just stay consistent with their naming so I don't get confused. And you can see that our negative 5 feet 11 inches matches their negative 5 feet 11 inches. Some projects, if you didn't do all of that acquiring project info or acquiring coordinates and all that, you may find that your levels are different. And so that's why we do that. It really comes down to where that project base point is, or even where the survey point is. There's a number of different coordinate systems in these projects. Now I want to create another level 1. So let's just copy it. We're going to copy here, from here, up to here. And I want to go straight up. And then I want to align this level. Align to 37 from there. And I'm going to call this. Now I may want to change the scale of this so my letters are smaller. So if I go from 1/8 inch to 1/4 inch, it means my annotations in effect shrink. So I'm going to call this on block 37. It just added 36 on its own. And then I also want a block 43. So there, I'm going to copy this from here up close, keep it perpendicular. And then I will do my align tool to make it exactly match block 43. I need a mezzanine. Let's copy this for a mezzanine and then align it. I'll just call this M1. And then level 2 I already have, so I can just align it and change its name to match. And I just did a break there. I didn't mean to do that. L2 and then L3 were actually, interestingly, they were close. Get that changed to L3. L4 aligns there. Another way to do this is to only have 1 or 2 levels in your template, and then you can just copy and monitor the architectural levels. And that's another technique that we've used. But then you have to create all of those floor plan views each time. And we've decided that I'd rather have 5 views made. It saves some time. And if I only have 3 floors, I can just easily delete the extra views. It's easier to delete than it is to add. And then we decided we don't need all these parapets. And I think we decided too, we didn't even need roof 1. We needed roof 2, which I can't see here. Let me change the scale yet again. 1/2 inch. There we go. We can see roof 2. So I'm going to copy this up to roof 2. That's why we looked at the architectural model, is to determine which levels we need. So roof 2, R2, and I think we even had R3 in there. Now, I don't know if we need R3 because I think it's just the roof of these stair towers which we have nothing on. So we'll leave it off for now. We can always add it later. But there we have our levels, and we need to add our parking level, I just realized. Let's go ahead and copy this down to the parking level and get it aligned. Parking. Okay, so now we have all the levels we need. And then the next thing I want to do is I want the grids from the architectural model into my plan so that I have control over them. I don't want to rely on where the architect puts them. In some of my views, I may want to move them around. So let's go back to our first floor power plan. And here's our grids. We have 1 through 9, and then we have A, B, and even a B1 through E. So we want to get those in. Now, a couple different ways you can do this. You can go up to the architecture tab and start bringing in grids and things like that. However, in this case, I like to copy monitor these grids, and it copies them exactly where they are here. What I do is go up to Collaborate, Copy Monitor, and monitor just means it's going to monitor if it changes. So if you open up your project sometime later and you get this notice that, hey, you need a coordination review, that means something changed that you were monitoring, or some walls moved or something. So this will kind of give you a little warning if things move. But we mainly want to use the copy. So we want to select our link to make sure, in this case we only have one link, but we want to make sure we're using our architectural link. So you kind of hover over it and you'll see it light up. Click on there. And then we go to actually copy. And it does a copy and monitor, even though it just says copy. Now we want to copy, monitor multiple grids. So click the multiple button. And then when we're done picking our grids, we can say we're finished. Now I can try to go through and pick individual grids with control, or I can simply surround the entire project. I have everything highlighted and use the filter. This little filter here is very powerful because I say check none, check grids. Voila, I just picked 28 grids with like 3 clicks. Okay, now I need to finish this selection. I'm not finishing the copy yet. I'm just finishing the selection. I'm finished selecting. And then I need to go back up and hit copy monitor again, and now say finish the copy monitor. Now if I highlight over these, you can see that they are in my project. I have control over them. I can move them around. Now, when I move these around, now this guy didn't stick because he is not exactly parallel. But you can see I still have the architect's grids in here. Now this is where I need to go in and change and turn off the architectural grids. So what I'll do is I'll go into my Power Plan 1/8 inch view template, which is part of my project template. Now I can go in here to the actual Revit link. I want to turn it off in the architectural link model. Right now it's set up to be controlled by the host view. Well, my project is the host. So my project is saying keep grids on, so they're on in the architectural. I want to change this display setting of the linked model to be a custom view. And I want to go to the annotations and make those custom. And this is where I want to go down to the grids. They're an annotative element, annotation. So I'm in my Revit link. This reminds you that you're in the Revit link because these menus all look the same. I'm in my link, go down to my grids and just uncheck that to turn it off. Okay again. And then there, the architectural grids turned off, and all I have left are my grids. And I can move those around at will. And this 43 has to be moved because it's diagonal. So there, we have our grids copied, and we can move them around as we like. So now that we have levels and grids, we can proceed to make the rest of our floor plans that we need. We've got 1st through 5th already, because that was in our project template. But now we need to make a parking level, and then we have a mezzanine level, and we need to set things up for those. And we'll need to set up some of these raised areas as well. So let's go ahead and do the parking level, and that is simply go up to View and Plan Views, and we want a floor plan. We're going to do the floor plan first for power. This shows you the floor plans that have not yet been created. So we have the other 2 levels that we can make. We have the mezzanine, we have the parking, and we have the second roof that we can do. So let's go ahead and just kind of an orderly fashion, let's do the parking level. And there is the parking level. And we know it's at the right level because we set up the levels earlier. And then we need to give it a name. Now I want these to be in order. What's between 00 and 01? Well, I can use something like a 00.1, any system you want. This is purely for organization. And we'll go parking level power. I don't want to rename the level for that. Now we can just pick them all, but I don't actually need these two other L1s to be production or sheet views that I drag onto a sheet. I'm going to do it all in one. Now I may want to make some coordination views for these. So let's do it that way. Let's make these coordination views. So this one we're going to make a 101.1. I do these in lowercase. First floor, we'll call this block, I think it was 37, plan, and we can just call it whatever we want. And then the next one, and I do these one at a time, just keep them straight, block 43. So 101.2, first floor, block 43, plan. Coordination, and then we can do the rest. M1 and R2, let's select both of these. We can select more than one at a time, and we will call this, it's between 1 and 2, 101.3, and this is actually going to be a production view, so we'll call this 01.1 mezzanine floor plan power. And another, the second roof will be a production or sheet view plan power. So now we have the rest of our power plans set up. We'll need to set up lighting plans. We can wait to do those until we actually get into our lighting plans. I'm going to start off with power. So let's go down to the parking level. We'll see what we have down here. One of the first things I like to do on a plan is to get the room names in there. Now, some people use spaces, and so they will create, it's an analyze issue, and they'll create spaces. You can do rudimentary lighting calcs with these if you want, just a kind of an average lighting calc. We do our lighting calcs outside of Revit, so we don't do that. And then for the HVAC folks, they like spaces so they can do some volume calculations, things like that. But for our purposes, we found that we're fine with room names. So that's how we're going to proceed. So we're going to go with annotate and do room tag. And the areas in blue have an actual room entity assigned to them. So we can place a room tag directly on these areas that have the blue. So that's the stair, and this is the machine room for the elevator. This is the main parking garage, so we'll get this out here in the middle. And these can all be moved later, which is very handy. That's stair 2. And we have the elevator E2, and this is another machine room and a storage. It's so nice having our own room tags on our own plan. This is the utility or electrical room. See, this does not have, it just says utility because that's what it was last. Or if I go from parking, that's what I had last. This space here does not have a room assigned to it. So we don't really know what it is. And then I want to get this guy. He doesn't follow very well the rules. We'll get him in there. So we have our rooms tagged. Now some of these rooms, especially at 1/8 inch, the tag becomes quite large. So one thing you can do, I can do it when I tag it, or I can do it now. Once you're in here, go over here to leader line, and then grab the little arrow and move this out of the space, and it leaves a leader. And you can pull this down here and do that how you like. You can also change these to have a ball or an arrow or whatever you want at the end. So if you go to edit type for your room tag, the leader arrowhead says none right now. We can put that into a dot filled. I like using a dot so that it's different than an arrow, something like that. And same with machine room. Go over here to leader line. And now if you grab the wrong thing, I got lucky there, but if you end up grabbing the circle and pulling it outside, you'll get the question mark. So that circle has to be in the room. Pull that out and get that lined up. So we can do that for these small rooms. And that looks good to me. So now we have to make the determination for our workflow. Now, you may have a certain workflow you follow when designing a building. A lot of times we like to get the loads in first. So I mean the receptacles, the motors for HVAC and plumbing, and the lights, and all the loads in first before we start circuiting anything. And we may send a whole set of drawings out with just the loads shown as a schematic design or even a design development level. And then when we get into CDs or construction documents, the next phase, then we will start fine-tuning. And a lot of that phase is rearranging some of these loads to keep up with the rearranging walls, which always happens, but also refining that and adding some electrical distribution and starting to circuit things and add up loads, things like that. So there's kind of an order to this progression that we follow. So in this example, I'm going to break it up a little bit. I normally, again, just do a full project, and that's how I did my previous project. I did a full project with laying out all the receptacles and motor loads, and I didn't circuit till I was done. This time, I'm going to break it up because of the video format. I will lay out the loads in this parking level, and then I will also start with some distribution so that I can at least get level by level circuited, and then we will tie it all in together with a full distribution system, get some feeders modeled, and we'll go like that. So what are we going to have down here in the parking garage? We've got elevators, so we can start there. To find out what you have for these various pieces of equipment, you can look at shop drawings or even catalog information from the vendors about what they need. You know, over the years, we've learned what elevators typically need, and it changes constantly. But the latest is when you have a separate machine room like this, they're going to have a three-phase feed to the elevator motor, whether it's a hydraulic pump for a hydraulic elevator or whether it's a traction elevator and it's a three-phase motor. But there's one big disconnect, usually fuse disconnect feed to this elevator. So I'm going to show that with a motor connection. Now, the other thing I need to mention in this tutorial is I'm going to be using the custom content that I use on our commercial work. My previous project series, I tried to use as much out of the box as I could, just so people can work through that and learn it without needing a bunch of custom content. But in this one, we're going to go ahead and use the custom content, and I have videos to show you how to create that custom content, or you can create something similar for your needs. I'm going to do it that way this time. So let's go down to my electrical fixtures. So these loads or endpoints are actually fixtures, whereas the panels and switchboards are electrical equipment. So what I have in here is a receptacle, equipment connection, and a motor connection. So I want this ER motor connection, drag it in, and you can see the symbol I have is a little motor symbol with a fuse disconnect. So we're going to say that's in here somewhere, and we can coordinate that eventually with the shop drawings. So what I do here is this is an equipment connection. It's just a symbol, but it has a power connector. So there's no 3D associated with this. This is just a symbol. I like to assign some voltage and load to this when I enter it, even if I have to change it later. I at least want to get it close. So I'm going to create a separate type for each motor connection because the type contains this information. It contains what classification it is, how many phases it is, its voltage, its load. So that has to be separate for each kind of piece of equipment. So load classification, I'm going to further classify this motor as an elevator. If you didn't have elevator in here, you can always add it. These are easily added. So elevator, and it's going to use the elevator demand factor. It's three-phase, and it is 208. Let's say that I found out from the manufacturer that this is a 55 amp, accelerating load, because elevators have not just a horsepower rating, but they typically have running load amps and then an accelerating amps and things like that. So I'm going to base this off the accelerating worst case amps of 55 amps. Again, you get that from the elevator manufacturer. So if I don't know how many VA that is, I can insert a formula in here. So I can just type equals like a spreadsheet, equals 55 amps times, well, 208 three-phase is 208 times square root of 3, which ends up being 120 volts times 3, or 360. So 360 is the magic number for 208 three-phase. So 55 times 360 will give me the VA. It's almost 20,000 VA, 20 kilowatts. And then the way we use our mechanical equipment schedule is we use this little guy here called type comments to flag whether I want this in the equipment schedule or not. Well, I don't want the elevator in the equipment schedule. I only want HVAC and plumbing in the schedule, so I will not flag it. And I have other videos that show how I use that flag to filter my schedule. And then down here, the type mark came in from before as an EF1, but I'm going to call this ELEV-1 for elevator 1. And I can put a description for myself and call it the elevator. And then also I want to make sure my type is renamed properly. I'll rename this first one, and from the future I need to duplicate it first and then rename it. So let's rename this one as elevator 1 also. That is just how it's going to show up in my list over here on the left. And then this is how it's going to show up when I tag it. So, okay. And then I can actually tag this. Go up here to tag by category. It has a leader, which I like. So then I can just hit that and then come out here. I'll hit that and it tags it there. And then I can take this and move it around to where I want. Kind of like a room name, elevator 1. And that has my special symbol that I've created, a custom symbol called ER Electrical Fixture Type Tag. So it's tagging the type mark. And then also in the machine room is a convenience receptacle. So over here to duplex. Now I need to bring in my custom duplex. This is just out of the box because it doesn't have the ER in front of it. I have a whole folder of my custom content and I can bring it in from there. Normally I would have that in my template, but as I'm still working on my template, it's not there. So load family. And it puts you into their default folder for family. And I have ER duplex receptacle right there. And I'm going to be having a EV charge station in here as well. So let's get, that's a bollard, which will be fine for this situation. Okay. And it up converts them from 2020 or 2022. Whatever you made those in. So here we go. So now I can just get rid of this duplex receptacle and use my own. The only thing different here, and I show, again, I can point you to where I make these. I created these, so I like my symbol this way with the circle against the wall. So let's get that in here. Now what I'm noticing is I'm seeing the actual extrusion box behind here. So let's go and see what's going on with the view settings of this power plan. This was created originally from the out-of-the-box Revit electrical template. Okay, so this whole power plan is set up as fine, and we don't want that. We want it set up as coarse. So that's something that I had missed apparently back when I created this template. So I'll have to take a note of that and fix that in my template. So there we go. Now we don't see the extrusion box behind this symbol. I only want to see a symbol. Another thing that happens with elevators is the cab itself needs a circuit for the cab lighting that they hook up. So let's get another connection here. Now this is not a motor, it's just an equipment connection. So what I have over here, another custom content, is this thing called ER equipment connection. So drag that in. I use this like a palette. And see, it's similar, but it's a different symbol. So this is for the cab power. I'll put that in. And this time, I'm going to go ahead and duplicate this one instead of renaming it. So I'm going to duplicate this and just call it cab power. Now I'm not labeling ER1 or ER2 because I'm not so worried that they're going to be the same cab power. Both will have the same kind of connection. And I can put two of these in. just has the same type. So load classification equipment, and it is going to be a single phase 120 volt connection. So this is right. I don't know the exact load, so I'll leave it bumped up around 1500 VA, which is a very conservative number for that. And this is already set up to be on the equipment schedule. I don't want it there, so I'll erase that. Its description by default was heat, and we're just going to call it elevator cab power. A lot of these are just notes for us, for our team. If you have other electrical people working in this, it's very handy to leave some documentation. And we will just call it cab power. I don't really have a special marker for that. And we'll leave it fused. And then let's also tag this thing with a leader. And we'll call this cab power. And it kind of fits in our symbol. Now we want to do the same thing to the other elevator. So what you can do instead of dragging them over is you can just right click and say create similar. And there we go. And come over here and pan over and put this guy right here. Now this guy we want to create our own. So we will go up here to elevator 1, edit the type. Let us duplicate this. And it tries to change the name for us and it failed. Elevator 2, we're going to say it's the same load. Its description is elevator. And its type mark is going to be LEV-2. So we're good there. And let's tag it. Elevator 2. We also need the rest of this, so let's just create similar for the receptacle. Save it when it wants me to. A good practice to get into. And then we'll put this guy in here. Again, you'll want to consult your shop drawings when you get those. But a lot of times we find ourselves actually putting placeholders in, taking our best shot until we really know what's going on later. In fact, many times I get asked to size the main service for a building before I've even designed it. That's a whole nother issue. So this guy, cab power, we're okay leaving it as cab power. And we'll get this drawn over here. Now, if you don't like where the arrow ends up, you can always click on here and say leader type attached end. You can unattach it, say free end, apply it. And then I have free reign over where this arrow lands. And then the storage room, sometimes I'll put a receptacle in a storage room. It's a design decision. It's up to you. Sometimes we don't. So I'll leave it out this time. Also stairway, sometimes we get a receptacle in a stairway for cleaning equipment. Another design issue, so you may want to talk to the architect or owner about that. But those are the main pieces of equipment for the elevator. However, we also need to remember that the elevator pit gets some power. So there's usually a receptacle in here for their maintenance, and they'll tell you where they want it. But let's put it over here on the side for now. And then also associated with an elevator, if you check your HVAC and plumbing plans, there may be a sump pump. Now, we'll be checking with the HVAC design and plumbing later. We're assuming right now that they're currently starting design just like we are, so we don't have their information yet to include. Eventually we will. And we will actually link their model in here for some three-dimensional coordination as well. Let's get that receptacle in here just for maintenance receptacle. So we're good on the power side. We're not going to put any convenience receptacles in the parking space itself. However, depending on where you are, you may have jurisdictional requirements to get electrical vehicle charging put into multifamily. Around here, up in the Northwest, they're requiring at least we have capacity for 40% of the parking spaces shall be, again, have the capacity for at least a 32 amp charger, so 40 amp breaker minimum at 208 single phase. So we've had to include those in our projects lately. So we're going to go ahead and put some charging in. And it looks like we have, we can count these up. Looks like we have about 20 spaces in here. So 40% of that is 8 spaces. And we want to make sure we get a handicapped in there. I always want to make sure we have a handicapped area that has a charger. So 1, 2, 3, 4, 5, 6, and then that handicap can have one, and then we'll say this last space can have one. So what I'm going to do for now is, again, we'll say that we've talked with the architect, we've talked with the owner or the powers that be, and decided where they want these charging points. And whether they're hooked up now or later, we'll deal with that later. But for now, what I'm going to do is bring in my EV charge station, my dual circuit bollard. Again, I have a video that covers how to create this custom content. I'll link it in the description below. Let's bring that in, and it looks like a charge point brand of charger. Now, in a garage, this would not typically be a bollard. It may be a wall mount. But I'll use this symbol for now, and we can go back and get creative with a wall mount if we want. But for my purposes, this works. So I'll get this near the wall, like that. And something we can do right now is look at this in 3D. Let me show you what we can do. We can surround this and then go up and hit this little guy here under View, Selection Box. If you hit that, and it depends on how big your model is, it will create a 3D view with this section box, it's called. This blue box here, that's the model. There's a blue box right there, section box, that you can grab these little grips. You can barely see them, but you can grab these little grips and move it up and down. And now I'm in the floor above, so pull it down. But it gives you a little 3D view of your space. Again, we're not doing a lot of 3D work yet. Most of our work electrically is in 2 dimensions. But this will give you an idea, and this shows my little EV dual charger right there. So it's a pedestal mount, and that's fine for now. We'll get that adjusted later. But for now, I just want to at least get this thing in and get it circuited. So here's our elevator shaft, and look how detailed they've gotten with even the elevator lights and the buttons. They've really gone to town on this one. We have the rails, we have so it's a hydraulic shaft. You can even see some of the lights in here that we'll be catching later. Those are in the architectural model. But that's a little 3D view. It's kind of fun to see what we're working on. And then I want to go back to my parking level power. This will serve 2. I need to copy this over and put another one here for those 2. We can get that a little more centered. And then let's say we'll do these other 2. And then we need 1 for this handicap. Again, I only have duals in here right now. So we'll use that. And we can just connect one side of it for now. And then I'll put another one way over here. All right, and then we can go into these, and these are all the same type. We don't need them individual. They don't have individual names. But what we can do is get a type mark in here so that when we tag it, we can put something like EVCHG for EV charging point. And as you know, the charger is actually in the car. This is just where you connect power to work the charger. So it's a charge point. And then we can tag these. I like to tag things so we know what these little things are. Now, if we want to call some of these future, we can create a separate type and just put future EV charge. Well, let's say we're going to get these guys all EV'd up right out of the gate. 1, 2, 3, 4, 5, 6, 7, 8. All right. So looks like we have our power needs for this parking level set up. And until we get some HVAC loads or plumbing loads, we may have some sump pumps, or we may have some exhaust fans in here, things like that. We don't have all that yet. But let's go ahead and get this stuff connected. So what we're going to do is start a distribution system. I kind of like to start off by creating a one-line or single-line diagram of my building. Well, I haven't gotten that far in this project yet. So I'm just going to start now at the bottom and work my way up and just put in some panel boards. If you have the luxury of doing it that way, it's kind of nice because then you don't have to do square foot calculations and load calcs and try to guess all these distribution boards up front. So we're going to say that we have time to do that, and we're just going to size this as we go. So what I have over here is some of my custom content, but what I'm going to do is get rid of all of these out-of-the-box pieces. Now notice that the out-of-the-box panel boards are separated. They have a number of families. They got 208 main circuit breaker, 208 main circuit breaker surface, a 208 main lug only, 208 main lug only surface, and you have all these different families. What I did is I went through and I just created a surface panel board, you can have any voltage, and a recessed panel board, you can have any voltage. I did the same thing for my switchboard. And I've not made videos on consolidating those yet, but I will make videos that will show you how I consolidated all these different panel board families into simple families that are adjustable. So let's go into Insert, Load Family. Down here, I have let's go down to my panel board. I have a recessed and a surface. They are different 3D geometry. And then I have an ER switchboard. So bring those all in. And they're up converting from 2022. So there, let's get rid of all these out of the box. I use their transformer for pad mount if I need it, which I probably won't. And I also use my own dry type transformer, but I'm not going to have any in this project. We're a 208 project. So it should be good to go. For distribution wise, we're going to have a main coming in, but we're also going to have a house distribution board that's on its own meter. Because this building has tenant spaces, like for retail, as well as residential units that will be all separately utility metered, we are going to have some meter banks. And we're going to be feeding a house distribution panel. So I'm going to put in a house distribution panel to run these elevators. So let's go ahead and just bring one of these panel boards. And here I'm going to use a surface panel board. You can see I already have the two voltages set up because those are type parameters. Let's bring in the 208. And let's just put our house panel. We're going to have our main panel and meters over here. So I'm going to put a house panel over on this side for now. This is my custom panel. It has clearances in front of it. And it has a door. So I'm going to call this guy. Let's first of all, what size are we going to make it? And you can see I don't have different types of sizes because the amperage of this is not a type parameter. It is an instance parameter. This instance of this panel board is going to be, let's say it's a 400 amp, and we can change it later. Now, I'm not going to have a main circuit breaker in here. Sometimes just for that reason, I'll put this down to 1. So then when I'm looking in here, I realize I don't really have a main circuit breaker. I can't put 0. And then I need to give this a name, and this is going to be called the house distribution panel. Let's call it HDP. Okay. And then we will tag this, and I don't want a leader. So there's our HDP. And then we want to connect the elevators. Now, it depends on the jurisdiction you're in, again, as to whether you need an elevator or elevators on emergency. You need a generator. You need 2 different utility connections for backup. So in this building, we're just going to say that this building does not require an emergency system. And we can put one in later for an example if we want. For now, we're just going to connect them all to the utility power HDB. So let's go through and get these connected. Now, this is a distribution panel, but we can also use it to connect other house loads like the receptacles. If we need to break it out into a separate, smaller panel, we can. But for now, we'll connect it all. So let's start with here with our elevator number 1 way over here. So you click on it, and then we have the power button. So you hit the power button, and then it asks for which panel do you want to connect it to. Now I can just drop down and find my panel, or I can say select panel, and then go physically find it and click on it. And if it's on the same floor and it's easy to get to, this is an easy way to do it. So now I've connected to HDP. It assigns the circuit in the order that we've chosen, and we've already set that up in our template to be 1357. We're going to go down the left side of the panel board and then down the right side of the panel board. And that's all in my video about setting up your template. So the rating on this, right now, we're going to say it's a 100 amp trip. And that can be changed later. Now the load name, it brings in the load classification by default, but this is the name that's going to show up in the panel schedule directory. That'll say, what does that breaker serve? So I like to be a little more descriptive. So I would do something like elevator 1 so that the end user knows what that breaker does. It's a 3-pole breaker. And we can say apply. We're still in the circuit. Now what we can do is we can add a home run arrow. Even though my one-line diagram will actually size this feeder, I'm not going to size it on this plan here. So it shows this as an underground conduit. As you can see up here, in a previous video I show how you can create dashed underground conduits. I'm going to leave it as an underground conduit right now because we most likely will run this under the slab. But I'm going to move it a little bit so it's not in the wall. And I can even move my little circle. And then I can give it a home run tag, no leader. And I have this set up with a custom tag for panel, dash, and then my circuits. And some people use a slash, and there's all different kinds of ways to do that. You can customize it however you like. And I have a video that shows you how to do that, which I'll put in the description below. And then I also want my cab power to go to that panel. So I can do the same thing, power. It's only going to list panels that are available at the voltage that this is, which is 120 or 208. And I only have one panel right now anyway. So HDP, it assigned it the next breaker in order. We already used 135. Now we're in 7. This guy, not just equipment, we're going to call it elevator 1 cab power, something descriptive. 20 amp breaker is good. So we apply that. And the wire type is underground again. And let's arc that. And I'm going to put that arc up here and get that dot right there. Get the tag on this home run. And then let's do the receptacle. Power it up, same idea. And we're going to call this receptacle elevator 1, or maybe machine room. Machine room PO2. And it's 20 amp, which is good. We're in commercial here. So arc it. That looks good. And tag the home run. As simple as that, those 3 things are circuited. Let's go look at the panel schedule so we can follow along. We need to create a panel schedule. Now what you can do is just click on this panel, and up above it'll say create a panel schedule. The other thing you can do is go up to Analyze and go to Panel Schedules, and it'll give you a drop down of the ones you haven't made yet, and you can say OK. And it creates a panel schedule, and that will end up over here in your project browser under Panel Schedules right there. And it names it the same we named it, and here we go. And we have this set up to show multi-pole breakers. It takes the dividing lines out of it, makes it one big cell, which is what I like. And it has the names that we typed in. You can see circuit description was that load name. We have things set up properly so that it divides up the loads amongst all the phases properly. Shows our mains rating. Now we're going to need to change this schedule so that we don't have a main circuit breaker. But then down here we have all of our load classifications nicely sorted. So we know the different kinds of loads and their demand factors. In this case, we're all at 100% so far. And then if we move this over a little bit, we can see the full panel. And it's a wide one. You can use the control key and scroll to shrink or enlarge the panel, just the view of it. So pump it up one more. And down here we can see here's our total connected amps and estimated demand. Since everything's 100%, it's all the same right now. But that's where we are. So now we can continue circuiting. Save it, of course. I realize we also did not get this elevator connected here. This guy and the machine room and the hoist, the elevator folks want those on separate circuits. So we're going to get this also powered up as we did before. Receptacle, elevator 1, hoist. And we can get tag on this home run as well. So we're eating up our circuits. Now we can do the exact same thing over here. I'll do that really quickly. And there we go. Simple as that. Now I'd like to get these chargers connected, and I often will put a separate panel board for the chargers. It leaves a panel board available for future chargers as they want. We can upsize it. And I just like to keep those on their own separate charger. You can also meter those separately if you like. Now, a lot of energy codes in different states have metering requirements, sub-metering requirements by the landlord, by the owner, to meter HVAC separately from receptacles, separately from lights. So if you have that situation, you'll want to break up some of these loads as well. And that's very much a local jurisdiction thing. And it's energy code. But for this one, we're just for convenience, we're going to put these on their own panel. So we are just going to create similar from this guy, create similar, and we'll put it right here. We'll call this one panel name. Let's call it EV for electrical vehicle power. And the mains, we'll have to see what we come up with for the size. For now, we're going to go 225. And also, this is where you put the maximum number of breakers. And if we need an 84 circuit, or if we only need 30 circuit, we do it here, and the panel schedule will follow suit. So let's get a tag on him, EV, and then let's get our EV chargers connected. Now, what we didn't do is, when we created these, we didn't go in and set them up. Let's see what we have. Yeah, so we're going to go ahead and set these up. We have two connections. Load 1, pole 1, voltage 1, load 1, and then classification 2, 2, 2, 2. So we have two different connections in here. So these are load classification. We have an EV charger load classification. We're going to go 2 pole, and we're going to go 208. These are just level 2 charge points. And the load on these, we're going to do the 32 amp ones. So it's 32 times 360, the magic number for 208 again. 2, voltage 208. And the load, and I just realized I'm wrong. It's not 208 three-phase, we're 208 single-phase, so the magic number is just 208 volts times amps. So that helps a lot. 32 times 208. There we go. Close to a 7 kVA charger. Okay. And that changes all of them because they are all the same type. But now we can circuit these one at a time. Power. And we're going to do connector 1 first. Again, I show in a video how to create this dual circuit charger. And let's call it charge point. And rating this is going to be 40. I've seen a lot of these level 2s even up at 100 amp connections. So that's good for like an 80 amp draw. And let's arc that. We've got 1 there, and we can give that. Now, look what happened here. I didn't pay attention, and it automatically assigned it to the last panel we used. I don't want it on HDP. I want it on EV. So what I can do is click on this and go up to electrical circuits and change it that way. Or I can hover over it, hit tab a couple times until you see those blue dashed lines and click it. Now I've selected this circuit and I can change it from here. So now what I can do is simply go to panel and drop down to EV. And look at that. It automatically put it onto EV13. So it's very convenient for changing circuits. So now we have another point. And as you can see, when I click on it, I still have the power button. Well, it's going to automatically to the power connector 2. So do that. I'm going to EV this time. I'm paying attention. And we're going to call this EV charging, charge point. And we have a drop down now. And then we can apply that. And then let's circuit that. And we'll get that down here. And let's put the tag on that. So that assigned it to EV5 and 7. Now these wires are going to be larger than a number 12 because we have a 40 amp breaker. So we can put wire size on here, or we can deal with it somewhere else. Some people put that on their panel schedule. So we'll come back and button all that up. We'll also check for voltage drop, things like that later. But for now, I'm just going to let this stand the way it is. And then here, we just want to power these up again. Connector 1, EV, change this, and we have a drop down now, so it's easy to put charge point and then arc it. And we're getting to easy mode now. And there we go. You can see how fast circuiting can be in Revit once things are all set up. And that's the key. It has to be set up. These guys, and I'll just quickly go through the rest of these. Now this one we decided to just do a single circuit, and we can come back and change the symbol and all that later if we want. Sometimes it's schematic design, level design development. I take a few shortcuts because I know it's going to change anyway. This whole parking lot could change configuration before we're done. And then we have the one more single circuit here. Connector 1, EV good, charge point good, and get a little bit of a curve to that one. And there, and let's go ahead and make a panel schedule for EV this way. Create panel schedule and use, let me see if I can choose template. Now I don't have yet in this template my main lug only branch panel, so we'll have to create that. Again, I'm still working on my template. If you watch my template video, you'll see there's a lot to it, and you can just keep adding on as you go. So here we go. We're down at 148 amps with those 8. So, you know, we've got another 80 amps available, and we may want to bump this up to a 400 amp panel before we're done, but for now this works. And another thing I'd like to do, I want to get a receptacle in this utility room, and I can just create similar, get a receptacle in here, and get this powered up to, now I'm not going to worry about underground for this guy. And we can change the wire type to just THWN. Nowhere will you ever see what wire type this is. If it says XHHW or THWN, the insulation type doesn't really matter in here. It's just wire. And it's going to call it a receptacle, electrical room, 20 amp, good, arc it, and get a tag on it. And you can see it's a solid wire. Solid wiring. It'll just be run surface in here. So I'm going to declare that parking level power for now is complete. Hey guys, this is Rob. Welcome to episode 2 of the Revit Electrical commercial project. In this one, we are going to be dealing with different floor heights. We're going to get view ranges set up for 3 different areas. We are going to start getting receptacles and panels installed in here. We're even going to learn how to create an enlarged view and turn objects on and off relative to different views. And then we're going to link in the mechanical HVAC model, get things turned on and off there so we can start getting some mechanical coordination going on in this all Revit project. So stay tuned. Let's get right into it. So here we are in our electrical model level 1, and this is a complicated level because there's actually like 3 different floor levels in here and associated ceiling levels. So let me jump over to the architectural model. We'll take a look at what they've done there, which will give us good clues into what we need to do. They're most familiar with the project since they designed the building. So let's get some clues from what they've done. I've popped over into the architectural model, which I have open as well. So if we recall the basics of the 3-dimensional setup in Revit called the view range, I have a video that I've done, and I'll link it in the description below, specifically about diving deep into view range and its associated subregions called plan region. What the architect has done is, and you can see in this view template, under the view range, they have a view range set up at a certain level. Now, the associated level they're talking about is associated level 1, block 35. They've set up this level as block 35 with a cut at 0, no offset, so right at the floor line. The cut plane, where it cuts the walls and doors, windows, all that, to form a floor plan, is at 4 feet. And then the top, we don't want to see all the floors, so the top is set at 7'6" above this level. Now, it helps to look at a section of this. So if you look at this section cut here, cuts right through the cafe and all the way through all of these commercial retail spaces. So if we look at the longitudinal section right there, we can see this is our parking level down here that we did in episode 1, but we're at level 1, block 35. There is also another level here that is not shown in this section, but it's called level 37. And then there's another level up here called block 43. So there's 3 different levels. Again, this level, it steps up to that level for quite a ways. So pretty much between grids 4 and 8 is that other level. And then it pops up once we get to 8 to this higher level, block 43. Now, what the architects did is they made an overall view range, and then they made some subregions with what's called plan region. If you go up to view, plan views, you have your regular floor plan, then we have a plan region, which creates a subregion in a view that you can assign a separate view range to. And in this little movie example, they're showing just making a region of a certain wall that has maybe high windows that you can't see with a cut plane at 4 feet. We may need to cut plane up at 8 feet. So you can create this little sub-region called plan region to do that. So what they've done is they've created some plan regions, and I've bumped up the line type so you can see them. All these green dashes are outlines of plan regions. So if we click on one, let's click on one of these, and it turns blue. So it helps to see it. We've got this blue line, and it actually dives in, and it's hard to tell, but it dives clear down here, up and over, and it pretty much encompasses, if you just take out this little dip, it encompasses this whole area here between grids 4 and 8 as a different view range. So we click on this and hit the view range. We can see that it is set up as associated with block 37, not 35. And it's at 0 offset for the bottom. The cut plane is at 4 feet above block 37. And the top is at 7'6" above block 37. So that is a separate view range for this region. Now they have a few other little sub-regions. They've popped up and down some of the stairways and some of the restrooms. For our purposes, we're going to try to just do the whole thing as one same view range and see how that goes. The other plan region is this spot here. And if we click on it, it goes way around here to catch this stairwell, because if you don't have the plan region, if I delete it, you will see that we don't see this landing. So I'm deleting the plan region, see what happens. We lose the landing, we lose this door. So let me undo that. That's why the plan region is here. So we can get hints from that. But this plan region is set up as view range of block 43 is the associated level. So it's the higher level at 0 for the bottom. The cut plane is at 4 feet above that. And then the top is at 7'6" above that. So this gives us clues as to how they've broken up the view ranges within this plan. Now, we could do the same thing. We could have one main view range, and we could have all these subregions and set up the view ranges with that. That's one way we can do it. Another way we can do this is just to create separate plan views of each of these regions on a separate actual plan view with a separate view range. And then we can assemble these all together on a sheet. So we can go either way. What I'm going to do for this example is do the separate view setup rather than subdivide it. I think it may end up being simpler to create, because in reality, when we start throwing devices in, we're going to have to do that on separate views anyway to get the mounting heights properly. So we're just going to do that. So let's use this as our key to how we're going to set this up. So back over to the electrical. Now we're going to create the 3 separate plan views based on the 3 separate L1 levels. And we're going to crop those views so that we can assemble them later on a sheet. Now, a couple things we need to remember: that when we create a view, it gets assigned a level. So if we go over here to Extents, Associated Level, L1 Block 35, it is grayed out. I cannot change which level this view is associated with. So the only way you can do that is by creating a new view. So we need to keep that in mind. We can't just change the association of this view to different levels. We have to create it that way. And the other thing is, to crop our view, we could just turn on the crop and we could just start cropping things around and turn on the cropping region and click on that. We could just crop it like that with a cropping region. And that works fine if you only have one view. Now we are also going to have possibly some technology views, or if we're going to have lighting views. And to make sure they are all exactly the same crop, what we're going to use is a scope box. Now you've seen me apply scope boxes to rein in the building versus the site. We're going to do the same thing here. So let's go ahead and turn off all the cropping so we can see the entire project. We're going to put in some scope boxes. So it's under View, Scope Box. And we are simply going to mimic this other scope box we already have, but we're going to cut it short. And we've learned from the architectural plan that grid 4 is our limit. So we're going to go to grid 4 for that limit. And let's see, we have a couple different dashed lines. We need to make sure we hit the right one, that one, and then stop at this other green line. Now that simply created a scope box, and here we can name it. So we're going to name this Block 35. We can apply that. And then we can tell it to use scope box Block 35 to crop our view. Apply that, and there you go. Now that same cropping is available for other plans by just picking scope box 35. So that was easy. Now we need to create a plan and a view for the next block, which is block 37. Again, we can't do it from here. We can't change it. So we need to create a new view. So under View, Plan View, we're doing a floor plan. Now, because it says do not duplicate existing views, it knows that I already did a plan view. I've already created some plan views here with some of this coordination stuff. So I need to uncheck do not duplicate. And I want to use level 1 block 37 to create another view. Now check associated level 1 block 37. So I'm good to go. Now I need to apply my scope box to this. So we will go to scope box, and we're starting at grid 4, and we're going to go clear up to this other one and get close. And then we also need to go to grid 8 is what we've learned. So grid 8 is the extent. And we will call this one block 37 to distinguish it from the other one. And then again, we want to make this view contained by block 37 scope box, and there it is. So you can see how easy that is. Now, one thing we need to do also is to label this. What I'm going to do is up here in my mezzanine, I had as 1.1 for sorting. I'm going to change that to something like 1.9. Again, that's just for sorting my floor plans. So then I can call this one 01.1 first floor still. And I'm going to call it block 37 power. And I don't want to rename the levels. And this one here, because it's block 35, let's go ahead and say B35 to distinguish that as separate. Okay, so now we have block 37. Now, one thing we want to make sure too is that we have the right view range on these. So let's check block 35, and we need to make sure we double click it so we have it active. And let's just double check the view range. We're using our view template, 1/8 inch view template for a power plan. And let's see what that view range is. We have 4 feet with 7/6. Okay. Now on this one, we have a -10, in case you want to show some underground work. So we don't need that. We already have one called level 1. So we're going to create the normal power plan as a 0 offset. So we can use that for upper floors. And then we want power plan level 1 to be different in that we do want it to be -10. -10. And we want our top to just be at 7, 6. Make sure that took 7, 6, 4. Okay. So we will apply that to all 3 of these power plans. We want this to be power plan 1/8 inch. Again, that's correct. Okay. Good to double check. And then we need a third plan. So let's go to view, plan view, floor plan, and we are okay to duplicate. We're going to do a block 43 now. And over here, yep, we're good. Block 43. We need to scope box that and start at grid 8. And go down to here and label this block 43. Escape out of there, and then we can make sure that we crop this to scope box block 43. Apply it, and there we go. And we also want to label this 1.2 first floor plan B43 power. We have our 3 plans all set up and they're ready to be used, and they have the proper view range and they have the proper base floor level. Now, one thing I'll notice here is that the grid lines are not cropping to this scope box like they should. This one does, but the others don't. And one thing you can do is sometimes you have to manually go through and do it. Now, we also have to make sure that the scope box intersects the grid and things like that. If it's showing in this view, it most likely intersects the grid. So let's go right click, say reset to crop, and there it goes. So we just need to do that with these. Reset to crop, and that will pull those in. Now, you might think, well, I can just manually drag this in, but that's a global drag. And so that would affect all the other views. So we just want to reset this to crop. Same with these. And then if we go to the other plans, now see, these all reset on their own. So no reset needed on these. So now we want to finally get into getting some electrical put into this plan. Now, one thing I want to take a look at is to make sure we understand architecturally what's going on here. We have the stair, we have an elevator, and we have this cafe kitchen here on the first level. And then we have an outdoor covered dining, and then we have kind of a park. And sometimes it's good to look at the architectural to get a better feel for what really is out here, to kind of see, you know, as you're actually making design decisions now on where receptacles should be, where equipment should be, where panels should be, you have to have a good understanding of the architecture of the building. So I've already got the architectural plan open, the PDF that I made. So here we go. So here we can see it again, pocket park, covered parking and dining. And there's already some sections cut through here. So we can look at 1 and 2 on 302. If we need to see some sections, we've also got a section here. But here we can get an idea. Here is that kitchen and the mezzanine above it. Looks like our park is kind of elevated above. So that's an exterior area. We're not going to put many receptacles out there in the exterior. We're going to keep them over here. So let's see what we have. We can put some out here in the dining area. Outdoor covered dining, but not out in the park. Something in this area might be helpful if they're doing some cleaning. So let's get a receptacle there. Now, receptacles. What we did on the parking level is installed a few receptacles here and there, and we just used our standard receptacle. What I would like to do from now on in this project is use our non-hosted receptacle to show you how much better these are and how much easier they are to use. A lot of the frustration in Revit, frankly, comes from some of the hosting elements not hosting properly. Trying to find a wall, trying to find a ceiling, finding the wrong floor. So I really have been pushing a lot of non-hosted families. So these are lighting fixtures. Let's go to our electrical fixtures. Now what I need to do is I need to bring in my non-hosted receptacle, and I'll put a link in the description below to show you how I created this. Load family. So ER, I have a duplex receptacle, non-hosted, and it's an R22 version. And it up converts to 24 just nicely. So now I can bring this in, standard. As you can see, I can place this receptacle anywhere, not just on a wall. So I'm going to go ahead and put one over here on this wall, and it will kind of snap to the wall. You can see it snaps there. And even in 3D, it should look proper. Let me go ahead and drop a camera in here and shine it at that wall. And let's see what that looks like. If I change it simply to a coordination view, then I can see there it is. So it's visible on the wall. It cuts the wall just fine. And this is a trash receptacle and a tray holder right there. And there's one there. We can put another one over here. So I'm going to right click, create similar. It's already at 1'6". I'm going to use the space bar to turn it. We'll put it right there. And let's see, we also have some wall over here. Let's throw it something like this. Not right here in the middle works good for me. And a lot of times you'll be working with the architect or working with the interior designers and such to help also place some of these devices. So we're taking our best shot right now. So if we go back to the architectural plan, now what we can see here is that they have done an enlarged view of this kitchen area. There's a call out right there that goes to 1K101. So they've taken this cafe, put it on a separate plan, K101 right here. And as you can see, here it is. And it's actually enlarged to 1/4 inch to the foot plan versus 1/8 inch. And this is so that they can have more room to add some leaders and some details. It's a good idea for us to go ahead and mimic that by calling out a larger plan. Now, I'm going to cut it so we don't see our elevator and some of this other stuff. So I can show you how we can do that. So back to our plan, we're going to do simply a view call out right here. And you can do a rectangle or we can sketch an odd shape, which is what I'm going to do. So I'm in sketch mode now. It's similar to what I did with a scope box, but this is now, I can use any of these tools. So I'm just going to use the line tool. And I'm going to do exterior walls. So I'm going to start, because I'm going to cut down through here. So I will start, and I want to cut here. So I'm going to start about right there. Draw a line over here. And I guess I'll include all of this in it. And let's go down. I just want the cafe. So I'm going to go here, and I'm going to be just outside the wall. And then just... I need these to intersect. Like right now, if I click OK, you'll see I'll get an error. Crop area sketch can either be empty or include one closed, not self-intersecting loop. All that means is I can't have this little tail hanging out here. So continue. I just need to click on this and back it off so that it's an exact connection. Okay. And it rounds the corners for me. And it puts a bubble in, and I can move this bubble like similar to what the architect did. I could put it down over here. Or sometimes it's easier to see up here, so I'll put it up there. And it doesn't have anything in it yet because we don't have it assigned to a sheet. Once we pull that view onto a sheet, it will label this appropriately. So there we go. Now what happened over here? It made a new view, and here it is. It adds callout 1 to that callout view. So let's go into that callout one and see what we have. And we can save the project. I recommend doing that every time it pops up. But what it did is it created it as an ER power plant 1/8 inch by default. That's what we told new views to do. We want to change that to a 1/4 inch plan. So let's click on this view template and see we do have a 1/4 inch plan called out already. Let's see what that is. And what do we have for a view range? We have to fix this view range on every view template that we use. So it's set up to level above for that view range. Now we can't use level above because in this situation, we have 3 level 1s. And we're at level 1 block 35. The level above is 37, which is about 2 feet above. So we can't use that as an upper limit. So this is the case where we have to use explicit offsets. We have to use an explicit offset on this. We can't use a relative. So we need to say this associated level with an offset of 7.6. Now, if we need to show underground conduits, we may need to make a power plan level 1 like we did the 1/8 inch plan, but we will see maybe we don't need to show that in this view. That's mainly going to be for the whole overall views. So that switched it down here to 1/4 inch for us. And we want to add some room names to this, or room tags. So annotate, room tag. Because remember, room tags are annotation. They only show up in the view they're created. It didn't pull those room tags from the overall view into here because they're separate views. So let's go cafe, kitchen, and we can move these around later. Here's the cafe itself. Now, these restrooms aren't blue. They don't have rooms assigned to them, so they will not show up. Now, we ended up getting the elevator in this view, which we don't want. Now, how do we fix that? Well, if we go back to our power plan and we've got enough views here where I can't get to it, I can also use this drop down here to get to any of my open plans. So let's go here. Now, you can see here my crop, I didn't bring it up high enough, but I can grab these grips and move it. You can also just edit the crop up here and actually go back to this edit or sketch mode and move these, and I can add more lines and separate these, and I can do any kind of sketch editing I like. So I'm just going to go up here and get right inside the elevator line there, because I want this elevator electrical to be part of my overall plan. So be done there. Let's go back to our call out, and there, it cropped it just like we told it to. Now I also want to call this something. And I will call this 101.8. And we can call this enlarged plan. Enlarged cafe plan. And we don't need this. Call it what you want. And then we can get rid of the call out itself. Something like that. Enlarged cafe floor plan. So now we need to start putting receptacles in. We'll leave the cafe kitchen last. Let's deal with the cafe itself. Now back to the architectural plan, because that's the one thing about a LinkedIn model is we have the shapes and the geometry and everything in here, but there's no labels, there's no tags on anything. Now we can hit tab over some of this and kind of there, highlight it, click on it, and we can see this is a vending soda beverage dispenser. And we can click on that, and that's a merchandiser dairy. So, we can kind of get an idea what some of this stuff is by clicking on it. Now, of course, it doesn't have any electrical information that we need. So this dairy, there's nothing in here about what it needs for electrical connections. We need more information than just their model. That's one reason I make this separate PDF. And many times, as we'll see when we get into the kitchen, we will get a separate set of kitchen consultant or kitchen vendor documents that tells us the details of the MEP connections. But for now, we're going to say this is a vending machine. We're going to say it's a standard vending machine we've done in the past. They're a 120 volt receptacle connection, and they're like a refrigerator, maybe 800 watts. So we're going to go with that. So let's get a receptacle in for the vending machine. And so let's go down to our receptacle again. And we are using our non-hosted standard. And we can put this up at 4 feet if we want. I'm going to leave it down at 1'6" and let it sit there. Now, I want this to be a special load, not just a 180, because right now it's just, if we edit type, it's just a standard. And we actually need to assign, that's a good point, we need to assign a voltage and a VA to our default. A lot of times it comes in with the load already there. So there we go. And our load classification for a regular receptacle, not the vending, is just receptacle. And that applies to proper receptacle demand factor, which, just as a reminder, is the first 10 kVA at 100%, and everything after that, above that, is at 50%. So that's all built into the load classification and demand factor. And I have a video I'll link below that shows the details of this load classification demand factor deal. So that automatically figures out our code loads for these connections. So that's standard receptacle. Now I want to go in and create my own new type. As you know, types are like a subfamily. They're a subfamily within a family. So I want to create a new type called vending. So I can just duplicate the standard, hit duplicate, and call it vending. And the reason I'm creating a different type is that I want to have a different load on it. And I don't want to change the load of all of my other receptacles. So I created its own type. And this one's going to be an 800 VA load. Now I can put it under receptacle, but I really should put this under equipment. And equipment, what does it use for a demand factor? Just 100%. Because if it's a piece of equipment, I want it to be figured out 800 VA, not added in with my receptacles. Now, one more thing I can do with this is I can tag this with its name. So if I go over here to edit type, down under type mark, I'm going to call this vending. I'm going to use all caps because it's going to be a tag. Say OK. And then if I go up to tag by category up top here on the quick access, and I hit that, you can see that I have already assigned this special tag with this special symbol around it for electrical fixtures. And I show in other videos how you can change which tag gets applied by default. But I'm going to say vending, and I have this giant box around it for other mechanical equipment. I can change that if I don't like it, but for now I've got room. I'm going to leave that. And I'm going to pull this down. So now it shows vending. Now I can detach this end if I like up here under the leader type, and you can see it's called electrical fixture type tag. And there's other kinds of tags that I can assign to it. But I'm going to unattach this end, say free end, apply it. Now it gives me a grip at the end of my arrow, so I can move this out here, for example. And that lets people know that that's a vending machine. Now this here, again, we don't have any electrical data for the merchandiser dairy. So without having that, we're going to assume that they told us it's just the same as it's a 120 volt receptacle, but it's maybe a larger refrigerator. Let's say it's a 1200 VA. So let's do that. Let's go ahead and create similar. Put it right here. And this one, again, because we want it to be a different load, we're going to create a separate type. Again, if I was to change this load, it would change my vending machine. I don't want that. I want its own. I'm going to call this one dairy. Dairy merchandiser. And let's say it's going to be a 1200 VA load under equipment. And I want to give this one a type mark, simply dairy. And that will just key in the electrician and anybody looking at this that this is some kind of a dairy equipment there. Pull it out here, give it a little shoulder. There we go. And I think on this one, and again, I'm only changing these are instance parameters here. If you go into the type, then you're changing everything. So I only want to change the instance to a free end and then pull that out. So there I have those. Now what else do I have in this architectural model? So I've got those. Now over here, we have a touchscreen register and a countertop. So we're going to need some power over here for this point of sale, POS system. So let's go ahead and put a receptacle. We'll make it underneath the countertop, assuming that they're going to put a grommet in, a hole with a grommet in there. So let's just go over here and get a standard receptacle. Now I can just take this venting receptacle, create similar, and let's just put it, spacebar, put it under here. I want to change this to a standard. So I can just go to here and just select my standard. See how I have now? I have multiple types under this family. I can just go standard. And now it changed it to my standard, and I don't have to change the load or anything because it's already 180. And then I want to get some convenience receptacles out here in the rest of the cafe. So let's just go ahead and duplicate this guy. We'll put one over here. And let's see, we'll get some down along this wall. Use the space bar to turn it. And then get space bar. Let's get one over here. And then I'd like one up here. That seems to give us decent coverage for up this hallway. And that looks good to me. And then we have these restrooms to deal with. I like to get a receptacle up here next to these sinks or lavs. So let's go ahead. We're going to do one called a counter. This one over here is counter. Now, the only thing different about it is it's set up for 3'6" elevation. So one here beside, and then space, space, and one here. And I have that symbology, as you can see, and that's actually part of the built into the fixture. If I go to edit type, I can turn that above counter fill in on and off as a type parameter. Again, I show how to create these receptacles in that other video. Now, I also like to add that these are GFCI, ground fault circuit interrupter. Now, you can get receptacles that have labels built into them that you can just type in. But the issue with that I don't care for is when I turn my receptacle, the label turns as well, and it makes it, I think, kind of odd to read. So I just use plain old text for these little labels like this. So there we have the main cafe and restroom area completed for receptacle layout. Now we will tackle this cafe kitchen itself. Now some kitchens, depending on if they're gas or electric, can have a lot of connections. So let's go back to our architectural plan, see what we have. Again, on this project, we do not have available to us the set of kitchen consultant drawings. So we're going to have to kind of punt on this one, and we'll see how that goes. But what we have here is, let's take a look at this back wall. Here we have trash can shelving, twin waste drain lever. This looks all like drains and washing, and this is shelving, stainless steel table, sinks, trash cans. This all looks like a scullery, I'd call it. So a mop sink. This is kind of a wet area back in here, so I can't see any need for receptacles back here. We mainly need them for the cooking and prep areas. So let's take a look at this wall here as kind of a cooking wall. And as we can see, we have a fryer, and it looks like maybe there's two fryers. And over here, this line way over here, refrigerated equipment base. There's a refrigerated base. We have a salamander, a broiler of some type, 4-burner range, smooth griddle, and a pizza oven. And then the hood, according to this dash line, there is a exhaust hood, most likely with a fire protection Ansel type system in it that we have to connect also. So we have a number of things to connect here. Again, no kitchen plans, but we're going to assume that they do have natural gas at this facility, and that all these fryers, broilers, and griddles and range, even the pizza oven, would be gas. So we are just going to need 120 volt connections for these for their controls. So let us get those going. So back in our plan, we need to get these two fryers connected. Now, what are we going to use for connections? We could use receptacles. And again, not having actual kitchen equipment plans, we don't know if it's a receptacle or a junction box with a hardwire connection or what it is. And a lot of times we have to let the kitchen consultant drawings dictate exactly how high they are and what type of connection they are. Since we don't know what kind of connection they are, it could be receptacle, whatever, I'm going to use what I call an equipment connection, which is a generic connection, and it has to be confirmed with the actual shop drawings, the actual kitchen equipment, whether it's a receptacle or whether it's a hardwired connection. So what I have for that is I have my own custom equipment connection. I'll put a link in the description below for how I created this. Let me bring it in. It's just a two-dimensional connection. And if you've seen my previous video to this, episode 1, I use these in the parking level as well. But they are just a special symbol that has a disconnect on it that we can turn on and off. So what I'm going to do is I'm going to put 2 of these for the fryer. And I'm putting it like that because I'm going to turn off this disconnect switch. So I have a couple things under graphics. I can turn off the fuse. There, it's gone. I can turn off the disconnect. So there, that way I have multiple symbols kind of in one family that I can just turn on and off. And again, I show how to create that. And that's just a two-dimensional symbol that has an equipment connection. I can connect it with my power button. So let's go ahead and call this. We need to call each of these a different type because they'll have different loads. This one's going to be called, duplicate it, be called a fryer. Fryer. It's 120 volt. Now I'm going to call this kitchen equipment. And the reason I'm labeling it as kitchen equipment, non-dwelling, so it's commercial kitchen, is, again, there's a demand factor, it's called the same thing, that does this. And this is based on the NEC. If you have greater than 0, less than or equal to, so from one or two connections, it's 100% demand factor. If we happen to have more than 2, but less than or equal to 3, so if we have 3 pieces of equipment, we can take a 90% demand factor. If we have 4, 80%. If we have 5, 70%. If we have 6 or more, we can take a 65% demand factor. Again, all by the NEC. So this automatically will figure that out for us, and it figures it out for each bus. So what I mean is, it'll figure this into the panel that we connect this to, and furthermore, it'll figure this into any upstream switchboard or transformer that we connect it to. So that's frankly one of the most powerful features of Revit is that it's doing our load summary and diversification and demand factors for us automatically, as long as we connect things properly. So we label it kitchen equipment, 120 single phase. The load on this, now we said this is just electronics, so we're going to put something like almost like a receptacle load. We'll just say it's a 180 VA electronics controls load. Could even be less than that. Now, the description and that kind of thing would only show up if we were to put this equipment in a schedule. And I would like to show you how I do create an equipment schedule specifically for kitchen equipment. I put a link in the description below for a mechanical, like HVAC and plumbing mechanical equipment connection schedule. But I'm also going to do something different here called the kitchen. So what I have here, I use this type comments to put a flag of whether this connection should show up in my equipment schedule. You won't see this flag on standard receptacles. I don't want those to show up, but anything I do want to show up, I put this flag. But I want to create my own kitchen equipment, so I'm going to change this to kitchen. Now, when I create my schedule, I can filter out only the equipment that has kitchen written in it under the type comment and only show that equipment in that kitchen schedule. So this is one way that we can schedule specific items, and I'll show you how that works. Now the description for this is going to be gas fryer, and I use all caps in my schedules. And now the type mark. On kitchen equipment, again, if we had a kitchen plan, you would see that they typically will number their pieces of equipment. And I have an example of a large kitchen that we're working on, and I'll pump that up here. And as you can see, this is huge. And so what they've done is they have an item number, KO1 is an air curtain, make and model, cold water needs, electrical needs, 120 volt, 2.4 amps, single phase, it's 6 horsepower, connect to the micro switch at the door. So a typical kitchen consultant will have this called out and usually provide cut sheets associated with all of this equipment for us also. But you can see that they've already gone through and figured out what's electrical. So this stainless steel 3-compartment sink actually has 4 convenience outlets in it. Now this one here is a high temp dishwasher with vent cowls and blah, blah, blah. And then here over here, it's a 480 volt, 47 amp, 3-phase connection. And it needs a flex conduit connection to a J-box. This is the kind of detail that we don't have for our project, but this is what you might typically see. And you can see they have a mark number with a K. Now, if there's multiple kitchens, they may have different numbers, not just a K. But again, this is kind of an idea of how this is typically done. But we don't have that, so we're going to have to make that up for this example. So we're going to say that this is K, let's just call it K1. So instead of putting a tag called fryer, I'm going to put the K1. And let's use a tag. And you see we end up with that shape of our equipment tag. Now, if I wanted a different symbol for these tags, I would have to just edit this family and create it as a circle. Now, I can show you that real quick here as part of this lesson, because it's something that's pretty common that you'll need to do is you'll want to make a custom tag. So let me show you how I do that. And then one thing to keep in mind is that I'm going to be doing this in Revit 24, but if your template, for example, is an earlier version like Revit 22 or 23, you will actually want to jump into that version and create this tag so that it will actually go into your template. But I'm just going to do it here for this project as a standalone. So I'm going to edit family. And because this is a totally different shape, I'm going to be saving it as a different family. But first, let's go ahead and change the symbol. So as you can see, all I have in here is a tag label, and that label is set up to be the type mark. There's a lot of things you can put into a label. You can put the model number, panel number, all these different things, but we have the type mark put into this label, which is what we want. We just want to change the shape of the surround. So I'm going to get rid of all these little lines, and I just simply need a circle. So I'm going to create a line that's shaped like a circle, and I'm going to make it right in the middle, and I'm going to punch it out. Now, how big do I want this thing? And this is in actual paper dimensions. Zoom in here a little bit. 1/8 inch circle. Now, will that hold K1, K2? I think I better make it a little bit larger. So I'm going to go out to 5/32 and call that, because I can get one letter and a couple numbers in here if I need to go up to 99. So I will do that, and then I'm going to save this as a family. And I'm going to call it tag electrical fixture type tag, and I need to add to that circle. And this is R24. I need to make sure I know what this is, so I can only use this on a project that's 24 or later. And I just want one backup. Say OK. So that was simple. And then I just need to load this into my project, and I can close out of this family editor. There. So let's go back. We're in our plan. We need to get to our enlarged plan right here. Now, nothing changed because we haven't told it to change yet. So now we can click on this, and up here, now we can change it to the one we want. So now we can go to circle. Right there. Now, you'll see that that tries to put it up there, but we can pull it down here. Also, something we want to do is make sure that we have an arrow on the end of this, and that's done as a type property. So the leader arrowhead right now says none. We want to go fill whatever you like, 15 degrees. There's that. And then again, I can make this end free. That is a simple way to change a tag, something that you might find very useful in your projects. All that done, now we can really cruise along and get another fryer in here. As we know, we have another fryer to connect. There's 2 fryers. So let's get another one in here. Now they're going to each have different mark numbers, but let's start with what we have. Create similar. Put that there. Now we want this to be a K2 because it's a different piece of equipment. If I was to just change this to K2, what would happen? Well, because it's a type, it would change them both. So I need to create a duplicate fryer, and we can call it fryer 2 if we want. And let's just say this one is type mark K2. So we want to tag this. Let's just go right click and do create similar and tag it there. Pull this down, get them lined up. So you get little dashed lines. The little blue lines help line things up. So there we go. And this will all associate back with our kitchen. Now let's make sure that we have, here we do, kitchen is turned on here. So what I should do now also is show you how I create this kitchen schedule. So what we do, we want to start a schedule. So under view, go over to schedules, drop down. There's the different kinds of schedules. There's notes and sheet lists and view lists. We just want a schedule of components or quantities. Now, a new schedule, what category of items do we want to schedule? We want to schedule electrical fixtures. All of our connections, receptacles, and all of these kind of things are electrical fixtures. Over here, again, in the side, they're categorized under fixtures. So that's what we want to do. And this gives you a generic name. We want to call this kitchen equipment, if I can spell, equipment schedule. And say, okay. Now it opens this schedule properties. And now this just gives us a list of available fields. So this means it's kind of like available parameters. What parameters are in these electrical fixtures that we want to put into a schedule? I'll go ahead and throw up here on the screen what this finished schedule looks like so you know what we're trying to do. So you can see in this schedule, we have these columns where it has the type mark, and it has the name of the equipment, and then it has electrical characteristics and things like that. So that's what we're searching for. So back here to the schedule properties, we need to start putting those items. So the first thing we want is that type mark. And then what you do is click on that and then use the little green arrow to move it over into the fields that we want in our schedule. Now the next piece I would like is our description of what that piece of equipment is. So there, we have description. Let's move that over. So next we want the electrical data. So down here under electrical data, go there. And then we want the panel and circuit number. So let's go down to find panel. And then we go up to circuit number. And then we're going to need, we like to put the feeder size here. So if it's 20 amp, 30 amp, 40 amp feeder, we like to put that here in this schedule. And we don't have that available here. So we're just going to have to use some other text that's available in this family. So I like to just kind of repurpose. So I'm not going to have a manufacturer listed for this. So I'm going to repurpose manufacturer to be the feeder. And I'll show you how that works. So let's say okay. Now it's going to show us the schedule that we created. And it's filling in right now a bunch of equipment. So what's going on there? And we can hit Control and scroll wheel to enlarge this. But as you can see, it does give us a type mark, description, data, and all that we want. And we can take these and we can, stretch them out. We can also rename these. So up here in type mark, I can call this something like mark number. Just mark, maybe even just like whatever you want to call it. And I can make this all caps, description. This can be electrical data. And this I'll put capital panel. So I can label these however I like. Just say circuit. And this one again, I'm repurposing manufacturer to be feeder. So how can I get this to only show the equipment that I want? Over here under Other, the fields are what we just did. We also, here's the rest of these: filter, sorting, grouping, formatting, appearance. You can also get to those under these tabs. Filter. This is what we want to do. We want to filter which electrical fixtures show up in this schedule. Now we decided we're going to use that comment type parameter to set our filter flag to be equipment or kitchen or nothing. So we want to filter by the comment tag. Now we don't have that available. So we're going to need to bring that into our fields. So back to fields, we need to add the type comments. There it is, type comment. And we can move it up top. So later on we can make that not show. But for now, let's use it as our filter. So now we have type comment available. We're going to make sure that the type comment equals kitchen. So that type comment has to say kitchen, or else it won't show up in this schedule. Say OK. And there we go already. It got rid of everything that doesn't say kitchen in it. So that's a simple way to use filter. Now, you'll find filters are super powerful in Revit elsewhere, and we'll be using those to turn things on and off here later as well. But for now, we're using a filter in a schedule. Now, we don't want to see this type comment. We don't need to see this. So now we can go into the formatting. And this is where we can get to all different things over here. But the one I'll call your attention to down here is called hidden field. So we have type comment highlighted, and we can say it's a hidden field. It just won't show in the schedule. It's still in there in the background being used for the filter, but it just doesn't show up. Now our panel and circuit will show up automatically. They'll be brought in from the model when we circuit them. So as you can see, this schedule is very powerful in that I don't have to recreate all of this information in a separate spreadsheet like Excel or a Google Doc. So I'm just extracting the data from my Revit model into here. The feeder will just be text, and I use a feeder schedule and tie it to a tag. So what I will do, for example, is on this, these are all 20 amp connections. I use something like 20-2 for and this says this change will be applied to all elements of the type Fryer, which is okay. It's a type parameter. And then also here 20-2. That just means that it's a 20 amp or 12 gauge connection, and it'll say 1/2 inch conduit, two number 12s with a number 12 ground. That will be in a separate feeder or branch circuit schedule. But that's how I create this kitchen equipment schedule. Now everything else I add in this project that I apply a kitchen flag to will show up here. Let's go back to our enlarged plan. We have all that stuff set up. Now, just as an aside, this is stuff, again, that can be set up and put into your project template so that every project you open up will already have a kitchen equipment schedule in it, or it'll already have a mechanical equipment schedule built in. So a lot of this stuff you only have to do once if you do it right and put it into your template. So what else do we have to connect? Let's go back to our architectural. We decided we have a broiler. And the 4-burner range, we're going to say, does not need a connection. The broiler, let's say it does. And then we have a refrigerated base, which is going to be electrical. We're going to say that we have info on that, and it's just a 120 volt 800 VA connection. So we will just create similar. Put that right there. And again, edit type, duplicate, refrig base. That's just a note for us. If you really take a look at the NEC, they don't want you to include refrigeration into the diversity factor of kitchen because it has a different cycle of use than just fryers and things like that. So we really need to call this refrigeration. Now, if we don't have a load classification for refrigeration, we can always make one. And again, we can put this into our template. So this also shows you how to do that. Let me show you. You can just easily say new and call it refrigeration. And then we need a demand factor for this load classification. And again, oftentimes it's the same name, so it can be confusing. But over here in the demand factor, we're going to create a demand factor. And this is where we get to apply the math for refrigeration. And we're just going to put that at 100%. It's not continuous load. It cycles on and off. It doesn't typically stay on for 3 hours. So we don't need to apply 125% demand factor, just 100%. It's constant. So, okay. So this is going to be refrigeration, 120 volt. And we're going to say that we found that this is an 800 VA load. And then we do want this to show up in our kitchen schedule, but it's going to be called refrigerated base. And this one ends up being, we're going to say on our kitchen schedule, it ends up being K3. So we can tag it, right click, create similar. And we're getting down here, something like that. Again, these all tie back to our schedule. What we have next is the salamander broiler, which is just a 120 volt connection, similar to a fryer. So we'll get that. And as you can see, each piece of equipment, just like when we do mechanical equipment, will be its own type. And it seems cumbersome at first, but once you get into it, it's not too bad. And so this is going to be called the broiler. It is kitchen equipment. And it's just a 180 VA load kitchen. And this is going to be called broiler. We don't need to say salamander. It's just a broiler. And this one's K4. And we can start putting some of these tags, right click up here. Now, as you can see, it moved that up there because there's a hidden disconnect up there. So I can either move this around till it drops like that, or again, I can just say free end and move it where I want. And then the range we're not going to worry about. We're going to hook up a smooth griddle to just a 120 volt control type connection. So that's going to be the griddle. Right click, create similar, edit this type and duplicate it. Griddle, kitchen equipment, same load, griddle. And this one's going to be K5. Apply that, tag it. Because this is in my own plan, I can move it around. Let's check our schedule and see things are properly adding on. You can see how handy that is. I don't have to retype any of this as a separate text or a separate Excel or anything like that. And then we have our pizza oven. We're going to say it needs 120 volt as well. Now, if this was an all electric kitchen, that would be quite a different story. We'd have a number of 208 two-pole connections, possibly some three-phase connections if it's a large enough piece of equipment. So let's duplicate this. Now I'm showing all of this without skipping through because a lot of you viewers have mentioned you like seeing the details, you like seeing the process. So we're going through this in painstaking detail to show you how I do this. Of course, you can skip ahead if you would like. Just stick around for what you want to see. And I'm going to go this side for this guy, and let's free end it. Free end and drag her down there. Now we do have a hood that's going to have fire protection associated with it, so it needs a connection as well. and it's typically at one end or the other. I'm going to go ahead and show it over here. So create similar right there, and then edit this, and I'm going to duplicate it and I'm going to call it hood. And let's say it's got a little more of a load because it's got some solenoid valves and things like that. We'll call this hood, and that's going to be K7. If I ever forget what K I'm on, I can look at my schedule. As you can see, no matter if I jump around this, it kind of plops around. And we can free end this there, and our schedule is looking good. Hood. I also will say that if you've done any kitchens, you know that under the hood, typically the fuel source, in this case the gas source, would have to be automatically turned off when there's a fire, when a fire detected. So associated with all of this, the gas connections, I need to turn off the gas valve. So we can show a solenoid valve on the gas line on here as well. So I'm going to make that a separate connection right here and call that the gas valve. If these were electric, we'd be turning off the breakers with like a shunt trip breaker, or they would run through a multi-pole contactor for lots of equipment, or just a 2 or 3 pole contactor that turns off a separate sub panel. There's different ways to do it. But in this case, because they're gas, we're just going to turn off a gas valve, which is just going to be a little 100 VA load. It's not really a kitchen load, so we're just going to call it equipment. Not that it's very much load at all. And we will call this gas valve. And I really don't need that to show up in my kitchen equipment. So I'm going to hit delete so that doesn't show up. And I'm just going to call this gas valve. So this is a different kind of equipment. This is actually more of a standard equipment connection like I would do down here. So I'm going to use this. I can either do a tag and then change it later to a different type, or I can just right click this tag, say create similar, and then it uses that shape. So there's a gas valve. So that's how I wanted to show that. So I think we're about done with this wall. Let's see what else we have on this other side. We have a table, trash can. What's this guy? This guy is a refrigerated prep table. Okay, so that's a refrigerated table. That definitely would be electrical connection. Again, let's say that we look at our kitchen equipment and we find out that that's a 1000 VA refrigerated table at 120 volt. So let's get that connected. And any of these will work. This guy, I really need to free end it, don't I? Okay. Go ahead and connect. Let's copy that down here. Call this our refrigerated table. Now again, it's refrigeration, so I really probably shouldn't put that as my kitchen load. So let's call it refrigeration. And it's 1000. It's in the kitchen schedule, yes. And it's going to be, I think, K8. Now, if I was to try to say the same type mark, let's see what happens. Let's say I said K7. Say OK. It's telling me that elements have duplicate type mark values. So cancel that, and let's go K8. And get that tagged. Now, if I just hit tag, it wants to use the old tag. I want to use this tag, so I'm going to right click, create similar, and get to that tag and free end it. Now, the next piece is this reach-in freezer and a refrigerator. Now, the reach-in freezer, we're going to say, is a 208 load. So we can see how to do that. So let's get our equipment connection over here. Again, this is my custom equipment. And then some of the stuff you can use Revit's built-in families. And in fact, my residential hybrid type project I did show how to use some of the built-in Revit families that you can actually change the electrical parameters for. But in this case, I'm using all these custom symbols, and I show you how to make them. Let's go and edit this one to be duplicate it, and this is going to be our reach-in refrigerator. Now over here it says load phase 1 or 3. Well, it actually can do 2. It's 2 poles at 208. So it's a 2-pole connection, line to line. It's a single phase, technically. There's only one sine wave, one phase of power. However, it's connected to 2 of the hot leads or 2 of the phase conductors. So we're going to call this 2-phase. That's how Revit identifies phase to neutral connections versus phase to phase connections. So that's why we're using the 2. The load we're going to say is 2 kW. And it's in the kitchen schedule, and we're going to call this reach-in refrigerator. And that type mark is going to be K9. Okay. So let's see how that looks in the kitchen equipment schedule. And let's separate these out. K9, reach-in refrigerator, there, 208 volt, 2-pole connection at 2000 VA. And we will put this tag on it and detach the end. And then we have the refrigerator, which again, we'll say this is just a 1200 VA 120 volt connection. So I don't want to duplicate a 208 load. Let's duplicate a 120 volt load so I have less to change. Edit that, duplicate refrigerator. And I just realized that I called that previous freezer a refrigerator. We'll go back and fix that. This is going to be a 1200 VA load. And this is going to be just a refrigerator. And this is going to be K10. Let me remember, this guy is actually a reach-in freezer. And rename this to freezer. So we can always go back and redo things. And again, create similar. 10, free the end. Now this end is an instance parameter, so it has to be done for each arrow. And I can get these up out of the line work just to be picky. So there we have our 10 pieces of kitchen equipment, and they all show up in our schedule. Now we can just leave it at this stage if we're doing something like a schematic design or even design development type of level of detail right now. And we would be circuiting these later. But for this example project, I'm actually going clear through schematic design development and getting into contract documents into the design phase to show you the full process. So to circuit these up, I need a panel. Well, what makes sense, I think, in this situation, because our electrical room is clear on the other end of the building. Back in episode 1, I showed that the electrical room, and let me show you here on an overall floor plan. Let's go down to the parking level. And you can see clear here at the east end, down here it's called utility. It's actually the main electrical room. We have a main distribution board. We have some panels. So our kitchen's way over here. So that's a long way to go with all those branch circuits. We're going to add a panel in the kitchen area itself. Let's go back to our enlarged view. And I want to put this panel in here. It could be up in this area. Could be over here. I'm going to add it like right in here. And it could be built into this wall. I'm going to recess it into this wall. Now, what I'm going to use for a panel is yet another custom family electrical equipment. what I used before are these recessed or surface panels. And what I would like to use in this project is my universal panel board that can be recessed or surface and be any voltage I want. And I have a separate video, which I'll link again in the description below, on how you can create that universal panel board. So let me bring that in. And our universal panel board, R22 right there. And I'm going to bring it in. And space bar. Now I can mount it surface or I can mount it recessed. But it goes on this wall. So I'll show you here, right there. Click on that. Now, what's nice about this is I can easily change it over here to recessed. Click that button. Boom. It drops into the wall recessed. These are my clearance lines that I can change either by stretching them or by actually typing in the clearance. So the clearance depth for this 208 panel, I'm going to put as 3 feet. Apply that. The width, I'm going to just make it, well, the minimum code width on a panel is 30 inches. So I will do that. And then the panel depth, I'm going to leave it at 6 inches. It's probably something like 5 3/4, but this is close enough. And there. Now, what I also want to do is make sure my voltage is set. This comes in at 208 volt 3-phase. I could change it to 480 here if I have a 480 volt panel. So it's very universal. And then I don't have a main circuit breaker on here, so this doesn't really matter. I'll make sure that this doesn't show up in my panel schedule. 42 circuits is what I'm going to start with. And it is already set to a 12208 Y distribution system. So we're good there. So it looks like we're good to go. The default numbering ends up being the default, as you can go back on my options and look, is set up for odds than evens. So it'll go down the left side of the panel board, then down the right side of the panel board. That's how I want it. So what I can do is start circuiting receptacles. Now I have the kitchen, I have the cafe, and then I have the rest of this block 35 to connect. Let's go ahead and start with some kitchen equipment. So I'm going to start at K1 and simply hit the power button. And then I get to select, which panel. Now, I haven't named my panel yet, so that's a good reminder that I really name this. So I'm going to hook it up to the universal panel board for now. But let me go back and name this. Now, this is the kitchen 102, so I can actually name this panel by the room that it's in. I think I'm going to call this kitchen. I'm going to call this panel kitchen. So down here under panel name, I'm going to call this guy panel K for kitchen. You can call it whatever you like. And then I'm also going to label it. And I don't need a leader, so undo the leader. Put it here, and it simply puts an underline K. Back to this guy. It's already circuited, and it knows it's panel K because I just changed it. But if I hover over it and hit Tab, I get a dashed line which says I'm hovering over the circuit, electrical circuit. Click on the circuit. I can add an arc wire. Now, on normal circuiting, I would add arc wires and I would put a home run and say which panel. But in a kitchen, that gets very cluttered. And that's why we have a separate schedule for the circuiting and feeder information. So I don't have to do it here. So I'm not going to show these home runs here. I'm going to let the schedule do the work. And let's go look at that schedule now. Now you will see that the panel and circuit number were filled in automatically again, pulled from my model, K1. So I don't have to type that in. Let's do the rest. K2, and now we can just get rolling. It remembers panel K was the last panel. Now, one thing I do like to also put in here, instead of the load name being just the load classification, which is the default, I'm going to say this is K2. Kitchen K2. Now, to know what K2 is, you'd have to go back to the equipment schedule, but that's okay. And then actually back here, I need to highlight this circuit, and I forgot to put the name. I'm going to call this K1. I'm just using mark numbers. for this kitchen equipment. So K3, power it up to panel K. See it jump, it calls it refrigeration. It's giving us its, by default, the load classification. This is going to be K3. And I can go through later and change all the breakers if I need to. Right now, I'm just getting this connected up. K4, power, change it to K4. And now you can see how quickly this goes, and I don't have to type up my own panel schedule. We will see what that looks like here in a second. Power this up, panel K, K, K5, apply, K6, and just go right through all of these. K6, K7, K8, power it up, panel K, K8, power K9, boom, K10, let's take a look at that schedule. Now, how do we create a panel schedule? We can go up to Analyze and say Panel Schedules. Or we can just go click on the panel, and right here it says Create Panel Schedule. Now, do the drop down. I can use the default, which ends up either being main lug only or main circuit breaker, but I'm not sure. So I want to make sure I choose a template. So I'm going to use my branch panel. And in this template I used, I don't have different kinds. So let's see what we get. This one, we get a main circuit breaker. So I will need to create a different panel schedule without a main circuit breaker so that I don't have this. I don't need a main circuit breaker, so I don't want it showing. So let me show you how to do that. We go to Manage. We can go to Panel Schedule Templates, and we want to manage the templates. Here's our branch panels. And I'll link in the description below, again, another video that shows everything you want to know about panel schedules and more. So we'll show you how I do this, but I'll do it quickly. I can edit this default. I actually want to rename this default to say branch panel MCB. It's a main circuit breaker panel. I want to make sure I know that. Now I also want to duplicate this. So duplicate branch panel. I'm going to do an MLO for main lug only panel. And then I want to edit the template. I'm editing the template. I'm going to get rid of this main circuit breaker. So here I am in the panel editor. Again, you can watch that video. It shows you about all this stuff. You can go through and change many things here. But my main point here is I don't need a main circuit breaker rating, so I'll delete that. And I don't need this text. That way it's not confusing to contractors and vendors, that they'll know that there's no main circuit breaker. Finish the template there. Now, it didn't change my panel K yet because I haven't told it to. So now I need to say change the template, change it to the main lug only version. Okay. And it's reminding me that any text entered into the panel schedule that is not stored in a parameter will be lost when the selected template is applied. For example, if I wrote something in here, legend, if I just added some verbiage that wasn't part of a parameter, it would be gone. Well, I'm okay with that. Are you sure you want to continue? Yes. So there, now I got rid of my breaker. I do want to put in, I'm going to guess right now this is a 225 amp panel. As I develop my loads in the load summary, then I can adjust accordingly. But for now, it's showing me that I only have 16 amps on this. And as you can see, and I can use this control again to zoom in or out. You can see that it put K9 in here as a 2-pole breaker and divided the load amongst the 2 poles. I had already set up in my project template that when I have a 2-pole load, I want this dividing line gone, and it just merges these cells. So that's why it does that. But as you can see, the panel schedule is getting filled out automatically as I connect things. Let's go back to the enlarged view. I also want to connect this gas valve, power it to panel K2, and I'm going to actually call this gas valve. Okay. And what else do I want to connect? I want to connect the vending machine, power, panel K, vending machine, apply it. And then, now these I can show a home run on. So let me tab over the circuit, and these I can add an arc wire. And I want to change where this wire ends up. So I'm going to pull it down here, and I can tweak this wiring. I have a video on the wiring. I'll link it in the description below on how wiring works in Revit. I'm going to tag without a leader this home run, and I've set it up with a custom tag to tag the panel dash circuit number. So you can do that as well. Now the dairy, power it. It's called Dairy Merchandiser. And right now I'm going to say arc wire. And again, I want to change the shape of this. I have these grips, and even I can move where that touches it. And then I can tag it. You can see how fast this goes once things are set up. And then it really flows quickly. And there's those. And then I want to connect this point of sale as a separate circuit. I don't want to tie it in with the rest of these. That's my design choice. Make it nice and clean. And we'll call this like POS or cash register, whatever you want to call it. Give it an arc wire. That looks fine. And give it a tag. And as you can see, the circuiting is just going down the left side of my panel schedule because I chose it to do that. Now, these receptacles, I don't mind being on one circuit because they're just going to be plugging in something to clean the floor. Maybe someone plugs in their phone to be charged, who knows. Small loads. So what I'm going to do is I'm going to pick one and circuit it to K, and then I'm just going to call this RE for our receptacle and cafe. And that drop there, cafe. Now, before I get done, I want to add the rest of these receptacles to this circuit. And I do one first for this next reason. If I say edit circuit and it automatically defaults to add to circuit, now I can't select anything except electrical fixtures. So it helps when if you're in a tight spot and it's hard to get narrowed down, it only lets you pick those. It won't be picking walls and windows and other items. So I like to pick one and then just use this to start adding the rest, and they darken up a little bit as we add them. So all those are added together. I can say finish editing circuit. Now if I want to add the arcs between them, I have to highlight the circuit again with tab. There we go. You can see those dashed arcs. That means I'm selecting the circuit, and then click it and then say arc wire. And it will arc the wires in for me. Now, some people don't show the arcs. You can also just add circuit numbers to each receptacle if you want. That's a separate tag that can be made. In this case, I typically show the arcs. That's kind of our procedure. So I'll get that home run. To me, it just really helps me and others visualize. And I'm going to move some of these to where I want them to hit. Those look good. Again, how picky you want to be, it's up to you. There, those look good. This one here, I may just extend it from here. And I can do that. I can take this and I can move its grip over to this guy. And stretch this all out to, if I want it to look more like what I think an electrician might do. Again, these are diagrammatic. They're not wiring diagrams point by point. They're just getting a point across that these are all connected. So there's that. And then also I want to get these receptacles connected. Now, do I need a circuit per room? That's a design decision you have to make. For me, I'm not going to do that. I'm going to put these both on one circuit. Now in this case, I can hold Control down and pick the next receptacle and then wire them together versus the way I just did the other one. Power those up, panel. Now, what happened here? Why can't I connect these receptacles? Something's wrong with the receptacles. Let's go look. Click on one and edit. Now, what had happened is I'd put these in and I had not yet assigned a voltage and load to them. So I need to make sure the counter receptacles also have the proper data. These are called receptacle 120 single pole, and then the VA is going to be 180, which is the NEC generic receptacle code. Now, it did try to circuit them, but it circuited them to, if I was to draw an arc wire, it doesn't know where to home run them to. So they're not even assigned. If you look over here, there's no circuit. It's called unnamed. So if you ever run into an unnamed circuit, that's what's going on. It's not assigned to a panel yet. Now, if I hover over this to select the circuit, so there we go. I can assign the panel up here now. Or I could even just click on one and go through and assign its panel. Now, if I assign panel K to that one, what happened to the second one? It also got put on K because it knows they're connected together. I already told them they're connected together. Plus, this wiring tells it they're connected together. So there's a number of things going on behind the scenes here. Let's tab again, and let's finish the arc wire, and it gave us a home run. Now, I show you in the wiring that you don't have to do this automatically. You can also do it manually. If you go up to the Systems tab, over here to Wire, drop it down to Arc Wire. Now, save the project. Now I can select this little circle that pops up, not the triangles, but the little circle, and that is the equipment connection point. And then a second pick to give the arc, and the third pick, so I can do my own home run, and I can still move this around. But the auto, frankly, works 99% of the time for me. This whole enlarged plan is circuited. Go out to our overall plan and continue circuiting. So we're in the enlarged. Let's go back to the first floor, block 35, and go from there. Now, one thing you will notice here is that I can see all of these receptacles and equipment connections and such in this view, and they're not circuited. So it might look kind of strange to have these showing up in this overall plan. Now, we can set this up so that these are only visible in the enlarged plan. And I've also decided I want to get a receptacle into this little elevator lobby. So I'm going to get a receptacle in here, and I'm just going to right click, create similar, and let's put that, just space it and put it about right there. So let's see what we're going to hook up the rest of these. We have 1, 2, 3, 4 of these receptacles. Those can easily go on one circuit. So let's go ahead and get those done, and we'll put them all back to this panel K. I do like to leave this panel showing in all views, and I do like it labeled in all views so we can find it. So I'm just doing a tag by category, and let's leave that K right there. So let's circuit this power to panel K. We're good there. Over here, we're going to call this receptacle outdoor dining. Some kind of descriptive, and again, this will show up in the panel schedule for this circuit as the description. And then let's go ahead and edit circuit, automatically adding to circuit the rest of these. This guy's already on there, and this one, and this guy over here. So now we can go ahead and tab over this to get to the circuit, and then go up to our arc wire, and it puts that in for us. And we can do all of our moving things around to make it look pretty. And hopefully you don't have to do too many of these. Now this here gets kind of close. I'm going to go ahead and pull this out here. And then I also want to move this around a little bit, but you can massage that how you like. And let's go ahead and get the home run. tag on here, right there, K35. And if we go back to our panel schedule, let's see what we have right there, K. As you can see, here's all of our kitchen equipment. Now this one here called Other, I failed to name it. So let's see where circuit K33 is. Now what I want to show you is you can click on K33 and then go back to your plan. Let's go back to first floor, and it should highlight. And as you can see, the blue K highlighted, it's showing a kind of a dash around the circuit, and these blues highlighted. So it's these guys that are on that circuit. Well, I need to go back to my enlarged, and there they are. They're still highlighted. So if you can't find something, you can highlight on the panel, and it will show up here in the model. So K33, I'm going to tab over this till I get to the circuit right there, click on it, and then I can type receptacle restrooms and do it that way. I could also do it in the panel. I could have done it right here, same thing. So there, that plan is done, except for one other item, and that's something we will take care of here also later in this video. We're going to link in the mechanical, the HVAC model that we have available so that we can connect up any of their mechanical equipment that's in this area. So we will get to that also, so hang in there. Right now we're going to jump over to the middle portion of this plan, which is block 37, and continue on with getting receptacles installed here. Let's go ahead and put in some room tags. And so I'm just going to plop these around. This is a commercial retail space. This is the residential lobby, a utility area, the elevator. And this is all the residential lobby. This is another commercial retail space. And again, the restrooms did not get rooms assigned to them. Now we could just add text labels for these if we want. But sometimes, you know, if this plan, let's say, is only at 90% completion, the architect may come in later and add these rooms, and then we can add our room names. Or again, we can just use text if we want to. So let's see what we need here. We're going to go ahead and do the same thing we did here with some restroom receptacles. Now I can go down and find these down here if I want, or I can also just pop back here, hit create similar, pop back over to my plan and go from there. Space bar to turn it. So we're going to throw a couple of these in here, space, space, like that. And let's get our GFCI label on there. And I can just copy this from here to here. And see how it cuts that off. So we want to be careful with the text. And then this is a commercial retail space. And let's say that it's going to be a future TI, a future tenant improvement. So we don't need to fit this all out now with, you know, we don't even know what this future commercial retail tenant will need. So we're going to put the bare minimums in just so they can have a place to plug in some cleaning equipment, things like that. But we at least want to get a panel in here. And let's say we've worked with the architect and everybody. We decided we'd like to get a panel back here by this kind of by the restrooms, by a utility area back here. So let's get a panel board in here. And again, we can go here to the kitchen and just right click the create similar and put this here. Now this could either be recessed or surface. I'm going to put it as a surface. So my universal panel board easily converts back to surface like that. And I have the same clearance width 2.6 and depth 3 feet. So we're good there. Now naming these panels, that was K over there. This one here, it's really not a name for this. I'm going to name it by the room name. So I'm going to call this something like P105. And it can be changed later, but at least for now we can get a name that's descriptive of where it is. So P105 will be panel 105. It's also going to be a 12208 4-wire Y with 42 circuits right now. And again, these can all be changed later, but at least I like to get something in here for now. And then I want to get some receptacles. So again, the lower receptacles are here. Let's just right click, create similar. You can see how quickly this goes. I'm just going to put a receptacle in kind of each one of these bays just to get things moving in this future TI space. Oh, it wants to go diagonal. Get these in here. And you can see with this non-hosted receptacle, I'm not fighting walls at all. And let's get one back here by this panel. And that should cover us for now. A lot of retail spaces by code need a receptacle here by a show window or a receptacle here for the sign. I'm going to let them add that later when this gets fitted out. So let's at least get these receptacles tied back to this panel. And 1, 2, 3, 4, 5, 6, 7, 8. Yeah, that's a lot of receptacles for one circuit. I'm going to divide it into two. So let's start here and power this up to this time. Not K, but P105. And we're going to call this receptacle, commercial, retail. And I'm going to do the north half with this. Or let's say, I'm going to do more of an east-west. Let's go east wall. Apply that. And edit the circuit. Add some more. Let's add these along this east wall to that circuit. Finish it. And then tab over it and hit arc wire. And I don't like these in the wall, so I'm going to bump these out like that easily. Click on it, pull the grip. And again, click on it, pull the grip. And this home run, it points it back to the panel on its own. I want to get this out here. Now this will affect the spacing of these wires. You can see that kind of spreads them out, and I like to pull it into there. P105, let's move this a little bit out of the way. Make sure I'm moving the right thing, not the whole panel. I just want the label. That can get tricky. Tab to get the label. There we go. And get this home run identified, circuit 1. Oh, I also want a separate circuit for these restrooms. You never know when someone's going to, I guess, bring in their own blow dryer or something in here. So I like to get these two receptacles on their own circuit, edit the circuit, add it, those two together. And we're going to call this receptacle restrooms. And applied. Finish it, tab to highlight it and arc wire it. And it just becomes just kind of a circuiting machine. And that is the center line, the actual head of that. Oh, I moved the grip. Sometimes it's hard to get to these. So where is, I may have to move this out of the way to get to, there's the bubble. And also a thing you can do is hit thin lines, and that will help things to appear as well. So we're good there. Remove thin lines. And let's make this guy over here. It's 3, and then these guys are going to go circuit them also to panel P105. Receptacle, and I can just click on this drop down and edit that so I don't have to type it all again. West, apply it, and edit circuit, add the rest of these, 1, 2, finish it, and then tab a couple of times, or once in this case. Sometimes it's 1, sometimes it's 2. Do the arc. Those look good. And I can just add a home run tag. This room is done. Now I also want to get a receptacle outside. This is kind of an entry area. Let's go ahead and say they want one out here. So I'm going to create a similar out there, and I want to add it to this circuit. So the way I can do that is I can just tab over the circuit, and then I can edit circuit and add it just like I did before. Finish that, and then I have to select the circuit again with tab, arc it, and it will add that last arc. I also want this to be weatherproof and GFCI. So I just add that tag like that, and we're good. So this space is done. Now I want to look at this residential lobby. So this is where they come in, and they can go upstairs to the residences, or they can hang out here in the lobby, and this is just a utility space. So I want to get a panel in for this area. And we have two different rooms, a utility and residential lobby. This is mainly going to serve the lobby. So I'm going to label this panel P106. Let's see, where do we want to put that? I'm going to put this along this wall here. So right click, create similar, spacebar. This utility area, so I can make it surface mounted and don't need to recess this. And we're going to call this one P106. Panel name, P106. There we go, and get a tag on it right there. And then let's see where we want to get some receptacles. Right click here and do create similar. Let's get a receptacle in here. And we don't know what all is going in here yet, so we'll just get these dispersed around the room. Because it's not a residential facility, we don't get all of the 6 and 12 foot rules like we would in a residence. We have a little more freedom. Let's see, in this lobby, that's a ramp. I think over here looks appropriate. And we'll come back to the restrooms in a minute. But out here, let's just get some mainly for cleaning. And they could, you know, put a little table and a lamp or something in here if they want to decorate up the residential area. So that's good for there. I like it. Now, let's add the restroom, and we want the above counters. Again, these have a symbol look, and they also have a height to them. If we were to ever drop a 3D view of this, or even an elevation of this wall, it would elevate properly. And these guys are GFCI, so I can click on that and hit copy, and copy that around and move it where I want. There we go. And then, of course, I need to circuit these to my panel 106. So let's start that. Do that, power it. You know, again, I'm showing every step here in case you want to follow along. And again, this is a publicly available model. You can easily download this, and you can even use, most of this can be just standard out-of-the-box receptacles and panels, and you can do just what I'm doing here for practice. Or if you want some custom families, you can follow along on those videos and make your own custom families too if you want to learn how to edit some families, which is a great skill to have, at least eventually. So this is receptacles in utility. Now, if you've done this in, or are currently doing this in CAD, you can see how there's a lot of shortcuts here once you've got things set up. I'm not having to go to my panel schedule and count receptacles and add uploads and all of that. It's doing it for me behind the scenes. Let's get these guys circuited. Add to the circuit that guy. Finish it. Tab. Arc. And once you've done it a while, it becomes, again, like a circuiting machine. And if I don't like where these circuits are, I can go into the panel and move them around simply, and it will update here. Now, the residential lobby and all of this is all kind of one thing, so I'm going to just get all four of these on one circuit. We're done with that section. Now we have another commercial retail. This is larger than the first. So let's see, we're going to put a panel in here in the back. So let's get that going. Create similar. And I'm going to put it back here by the door. This is most likely the area that will be a utility area for this tenant. And we will call this one, it's 108. We'll call this one P108. Apply that, get it tagged. And then let's get some receptacles in the restroom. This is, you're seeing the pattern here, so I'll go ahead and do this quickly. Okay, and let me circuit these. Now, one thing I want to note too is that we have some steps in here. So we have some height differences. So I'm going to draw a section on this sidewall. It's going to act like an elevation. And we need to get this set up to section electrical distribution. So what do we have here? So we have some receptacles that are low. We're seeing some receptacles block 35. Well, why are we seeing those? We're seeing the other side. So we want to pull our section back to only look at ours. So I'm going to make the section go there. Let's try that. Now we only see ours. So block 37, and it looks like we're okay here with height. The receptacle. So we're good there. Now one thing I can do, because see all these tabs, I'm having trouble getting to them. Let me go back to the tab I want, and I can go up here to this guy here and say close inactive views. And that will close all the other views and get rid of the tabs except for the one I'm in. So I've got that. And I think I'm good on this side too. I don't have any elevations in here. Now in this one, I've got some steps. So I've got some elevation issues in here. I'll move this section because this is just a section I'm just using for kind of a working section. Let's see what we have here. Now we can see that this is an elevated level, so our receptacle is too low. So we want our receptacle to be 1/6 to the center. So let's see what our offset is. I'm going to move from here to there. It's a 1 foot. So I really need to bump this up to 2'6". 2'6" works. If I want, if I want the elevation to look right, if you look at it. Now, it may not be important in your project to be perfectly, accurate in 3D. I like to do it where I can, just in case an architect comes in here and wants to start looking at things and do some checking on heights. Now, it looks like here it drops down. So in here, I'm okay. It's just these that I need to raise up to the 2'6" level. And that one and this one. 2'6". And those will look right in 3 dimensions now. So I can get out of thin lines. And then same with this one. Let's move this section in here and see what's going on. And I'm moving it so that my boundary is in the middle of this wall. So I only see my space 108. So again, these guys are okay, and this guy is not. So what's the differential here from the level to the top is 2 feet. So this guy needs to be at 3'6" from block 37. Okay, those look good. And I also need to make this one up at 3'6". Again, it only shows up if you look at things in 3 dimensions. All right, so let's finish. I'll just quickly finish circuiting these up. And maybe you noticed that I had these to the wrong panel at first, but it was easy to just go up and change them. You can just get into the circuit here and change the panel and easily change that, and it moves the loads and everything for you. Okay, so now we've got that section. Now we have one section left, this far east block, and that one was called block 43. Let's take a look at that. In here, let's get some room tags. This is also another commercial retail space, and there's our stair S3. And let's see, I think we also have, doesn't say, there's a little lobby in here that goes up. So let's go ahead and get a panel into this commercial 109. So we will call that create similar. And let's get that right here. Call it P109. Okay, and tag it. Now it's receptacle time. Let's do the restrooms. So let's see, I've got a kind of a bay. Let's put one in each bay. Now this one I want to turn at this angle. So if I hold it over this wall and hit space, it will start conforming to that angle. So I can get that in there. And I'm going to put one out here in this lobby. Kind of a stair lobby, just for cleaning. Need to plug in a vacuum or something. Now, as far as circuiting, I'll have to see how I circuit this. I may circuit this to something that's upstairs. So I'm going to leave that uncircuited for now. But let's get the rest of these circuited. So we are done with circuiting the receptacles on this floor. We have a few things left, though, that I promised we would deal with at the end. First thing is we want to go back and B35 view, and we have to zoom all to get to it. ZA, there it is. To get to it. Now, this one, we don't want these pieces of equipment in here to show up. What we've used in the past is set this project up for work sharing and then used work sets for visibility. Now, that's not really the intent of work sets. Work sets are really, if you read the literature, it's really made for controlling the performance of your project. If you need to turn off work sets for certain systems so that it doesn't bog down your graphics. It can be used for visibility, but the more flexible visibility control is to use filters. So all that means is we are going to use a filter and a flag or tag on certain pieces of equipment that tell it whether to show or not. So what I can do is I can put something in each of these. Now I have to go into each of these and add a parameter that the filter can use. Similar to what I did with the kitchen schedule. Let's remind ourselves what I did there. We used the type comment to add a flag called kitchen so that it can be filtered in our schedule to only show stuff called kitchen. And that was done in the type. Now, what I need to do here is I don't want to do a type parameter because I don't want all receptacles. If I was to do something in a type parameter, then this is a vending, not a good example, but all of the standard receptacles, if I did something here, if I set these up with a flag, then they would all turn on or off. I only want certain ones. I only want the ones that are in my enlarged view. So let's go to my enlarged view so I can make sure I'm dealing with the right ones. I'm going to simply add a flag here that says these should only be shown in the enlarged view. And it may seem cumbersome to do this to each one of these, but I would have to do that if I use the work set method as well. So what I'll do is I will go over here. Now I have some instance parameters that I can change that are built in. I'm going to use the one comments. I'm going to let this comments field be where I put the flag for where I want this. And I'm just going to put in enlarged. That means that this piece of equipment only shows up on the enlarged plan. And I'm going to do the same here. So I need to go through. And now once I've put it in, I can just drop it down, which is nice. Now I can do this for a number of pieces of equipment. I can go ahead and because I can click the model itself, let me go over here and say, I don't want to select pinned elements. I can change what I can select here. Now I can go through these, and I can get to all the comments, which says varies, and punch them for enlarged. So that's the way I can do this to a number of pieces. Now, I could do that with a lot of things, but the problem is now I've got wires and tags all selected. I could go through and filter. Again, this is just a selection filter, not a view filter. I could selection filter and get rid of the wires, get rid of the tags, and say OK. And then I can go over to comments and say enlarged. And I could do that with the entire view. So again, let's take the entire view. Let's do a selection filter. We've got all kinds of things here. So check none. All I want is I don't want the equipment, because the equipment would be my panel. I don't want tags. I just want the fixtures, 24 electrical fixtures, which is receptacles and equipment connections. Okay. And it's going to say varies because some are, some aren't. Let's say enlarged. Apply. That's simply done. Now, let's go back to our first floor plan. Now, this is where I'm going to apply the filter. So let me show you how that works. And it's going to be in this view template. So view template, I'm going to go right here. VG overrides filter. Edit the filter. I've already got some filters in here for my underground conduits and wiring. And I show this in another video, which I will reference in the description below. We're going to add a filter, but we have to create it first. So here we need to edit or make a new filter. So this one's going to be called, here's all of our other filters. We're going to make a new filter called enlarged. For enlarged view. There, enlarged. Now, we're going to be setting up what categories will that filter affect. Well, we only need it to affect the electrical fixtures. And then here's where we put the rules for a filter. So this is an AND rule. You can have an OR rule. So we can apply some logic to this if we have multiple things we're checking against. We only have one thing we're going to check against, and that's check for that flag in the comments field that says enlarged. So we're going to say the electrical fixtures and which part of the electrical fixtures we want the comments tag. And then we're going to set up equals, does not equal, is greater than and equal. We have all of these conditional statements. So we can say even just if it just contains enlarged. If it contains the word enlarged. I could say equals, but the power of filters is I could have multiple words inside that comments box that applies to different filters. So I'm going to say contains, and that's our filter. So if it contains enlarged, then that is the selection. So this is the selection for it. And say, okay, now what are we going to do with that? So we're going to add that filter called enlarged to this list. We're going to enable this filter because we can disable it easily by checking this. But what do we want the visibility of that enlarged to be? Right now it's visible. I want to make it not visible. So the default visibility is every electrical fixture shows up. This filter now says that if it says enlarged, we're going to make it not visible. So it's kind of, so right there, those just disappeared. So the first time you do this, it's kind of confusing. It's kind of, to me, almost like a reverse logic or negative logic. But the base logic is, think of it like a code exception. The basic code here is that we want electrical fixtures to be on. We have that category turned on in our plan right here under the regular visibility. We say electrical fixtures shall be on. The exception to that rule is the filter that says things that are tagged as enlarged will not be visible. Now we can change it to be different line types and different patterns, which is what we did for underground wiring. So you have a lot of things you can do to control how it looks. We simply want to make it not visible. Now it's still in the model. It's still circuited. It's just not showing up in this view because of this view template. So there's that first extra bonus feature. The second bonus feature, we want to get the mechanical HVAC equipment in here. So how are we going to do that? First of all, I want to make sure I save this project. The mechanical system is also downloadable from the Revit site. And in episode 1, I show you where those are. So I've already got it downloaded, and I'm going to insert a link Revit like I did the architectural link in episode 1. Now I have a thing called XREF, which we used to use for CAD, but it's an XREF, or an XREF is similar to a link. Now what I have is Snowden Towers sample HVAC, and I've got a few backups for it. I've been into it, but HVAC R24. Now, what's important is, where am I going to put it? There's a number of origin type points in these models, and there's an origin. You can just go center to center. There's shared coordinates. There's project base points. There's a survey point. There's a number of points in here. We are going to go with project base point to project base point to line these up. Okay. And what it's telling me is that the following nested links will not appear because their reference type is set to overlay. The HVAC model has all the other models referenced into it as well. So because they're set as overlay, they won't show up. So it's not going to show nested links, which is fine. We don't need all those links in again. So there we go. Well, nothing happened. Why not? Let's find out. So I've already made a PDF of that model. Let's go see what that looks like. And here it is, the HVAC version of it. We're going to click through and take a look at HVAC level 1 is where we are. So what we are expecting to see is a heat recovery unit, HRU 105B here, and here's all its ductwork. And here's this one's not labeled. Again, these plans are not quite done. Another HRU here, and then here we have just ductwork, and it must be going to something maybe above. Right here, sea level 2 for HVAC equipment, sea level 2. So we have 2-story elements here. Now what's happening over here? We don't show anything in this area. Now if we click on level 2, now we're starting to see some equipment up here on the mezzanine, and here they are up in the commercial retail up high. So we have stuff on the second level, but let's go back to that first level. We want to make sure we can see these inside our units. So let's go back and take a look at that. Let's go to our B37 and see if we're seeing anything. And we're not. So now we need to check to see if we even have the HVAC equipment turned on. So because if you go to the power plan view template, and if we look at the Revit links itself, here we see we have the architectural HVAC. Now the control of these, the architecturals, we have a custom settings, but the HVAC, we have it by host view, which means our electrical model is the host. However we have that set up is how the HVAC is going to be set up. So we most likely have HVAC turned off. Here's our electrical. This is in our electrical model itself. See, we have ducts turned off. So the Revit link is using our host settings to decide whether it's shown. So we don't want that. We want the actual HVAC model to control its own destiny. So we're going to make this custom. And we're going to go in the model and set that custom. And we want to make sure that we have ducts all turned on. And we want flex ducts. And we want mechanical equipment to show. So we want all that stuff to show. And this is just HVAC. We're not expecting any plumbing. The other thing I want to do is I'd like to make sure these are all halftone and underlay, which I hadn't done yet. So let's say, okay. They still don't show up. So now I'm starting to think we have a view range issue. Let us take a look. We know from our PDF that we should have a unit showing up here. And we can't tell from PDF how high that is. If we take a look, let's go look at our section. And we're over here. Here's some ductwork. Let's make sure that our section is punched clear back here so we can see. And what do we have? Up here, I'm going to highlight this right there. That's a heat recovery unit. And it's up at 9'10". So we don't have enough height on our view range to see that. We need to be clear up to level 2. From wherever we are. We are in block 37. So we need to make this view range higher. So from block 37, we need to go up to L2. So we need 11'6" for a height. All right, 11'6". So let's fix this view range to 11'6" and see what happens. There. Now we can see all of this. We see the ductwork, and it's a single line here because of how we have things set up as fine or medium or coarse. We really only need right now for connections to see the actual unit. This is where you can decide whether you want the actual HVAC model pieces to show in your plan or not. I typically like to have this stuff showing in a coordination plan so I can coordinate and clash detect, things like that. But I don't necessarily want all this stuff showing in my actual electrical plan. So what I would really do is on this plan, I may say just show the unit and not the ductwork. So I may go into the Revit links here and customize it so that I don't see the ductwork. So I may get rid of all the duct fittings, and I will customize this view so that I only see the unit, which is nice to have in here. Some people will take this unit and they'll just draw a box around it in our plan and then turn off the unit. I'll leave the unit on here. Now, one thing I forgot to do is change this flex duct, so I need to go catch that too. Again, I'm in the link and I'm in the custom section of the link. And let's go to flex ducts. There we go. So you just have to tweak that a little bit, but that's the joy of a view template, is it will show that way everywhere. And I can also see that I want to move some of my tags in relation to that. There we go. Now, again, for coordination, I can go down to my coordination plan here and turn on ductwork, make it fine so that I can coordinate, especially when I get into lighting. And I have ductwork and lighting all clashing up here in the ceiling space. But for now, I'm just looking for these units. Now, what is that unit called? As you can see, when you bring in a HVAC model, there's no labels, there's nothing. So I can either relate back to this 105B, and I'm going to assume this is 105A. Also, sometimes in our model, we can tab on it and see if something comes up. Now, it looks like, yeah, the mark 105B. They did label this, so that helps us. Now, what I'm going to use for equipment connection here is what I've used previously. In episode 1, I showed my motor connection, not equipment, but electrical fixtures. I'm going to use my motor connection. I did it with my elevators. So I'm going to drag a motor connection in, and I don't know exactly where it needs to be, and it may not matter, but I can show it something like this, and I'm going to edit this and duplicate it and call it HRU 105B. And then I'll need to find out, first of all, it's an HVAC. So I will change this to HVAC for a load classification. Now it's load and voltage. I'm going to have to check, cut sheets or a mechanical schedule to figure that out. So I'll have to figure that out here next. But again, on my type mark, I want this to be tagged as 105B. And I also want this to show up on an equipment schedule. So on my type comments is where I'm going to use equip, not kitchen. So I'll have another schedule for that. Now, I've decided I don't need a fuse disconnect here. I can coordinate with the mechanical engineer, mechanical designer to figure out if I do need a fuse on that. A lot of times for fault current reasons on big units, we leave fuses, but we'll coordinate that. But let's see if we can find out what's going on here with 105B. And we may need to go to a schedule. Again, you can only learn so much in the actual linked model. Now, this is just a space schedule. Let's see where they have their equipment schedule. It may be further on in these plans. And they don't have any schedules here. So all I can assume is that this project that someone did, their schedule is off sheet, or it's cut sheets, which we don't have access to. So we're going to have to make some assumptions here. So we are going to make some assumptions that, based on previous projects, we're going to say these are 208 three-phase units. So we're going to assume that they're a 208 three-phase unit, and they're something like, 3,000. Again, for our purposes, we're just making some assumptions here. And I can actually tag that with a leader, and that should show up. Now, what this is showing up is my circle that I used last. I actually want to change this to my hexagon symbol, like that. And I need to get this circuited. I'm going to circuit it to P105. So power it to P105. Let's drop it down to 105. And we're going to call this HRU 105B. Apply that. And now, because I'm going to schedule it, I don't really need to arc it, but I like to do a little bit of an arc. And it reminds me graphically that I have circuited this. Like if I look at my plan here, I can see that, oh, there's a home run, I've circuited it. But the actual data for this is going to be on the schedule. Now I have another one down here, and if I tab over it, I can see that this one is 105A. So I will do the similar thing here. And I'm going to say it's the same electrical characteristics. So I'm just going to create similar. And it's already set up with the proper electrical characteristics. So I just need to make sure I duplicate it and make it a 105A. And same thing here. And I want to make sure that that doesn't always get duplicated. Make sure it shows up as equipment. And then I'll be able to add descriptions and such later. But for now, we're good. And we're going to tag it. Now, the reason it keeps going back to the circle is because that's kind of the default that got set. I can change the default by going up here and doing right-click, create similar. Now that sets the default to this symbol. And let's get this circuited to 105. This one's going to be HRU 105A. Apply it and arc wire it. And that's good. Now, if I go look at my panel, and that's the other thing, I haven't created panel schedules for all of these. I can click each one and say panel schedule. I can also go up to analyze and say panel schedules, and it will show me all of these are not done yet. So let's check them all and say, yes, let's create panel schedules for all of these. Now it's going to use the default panel, which is the main circuit breaker. So I will need to change the template back to the main lug only. And here we are. And another, looks like I didn't label one of my receptacle circuits for 105. So I can click on that, go back to 105. There it is. And there's the receptacle. And look at that. I didn't even hook these up right. So that's another thing, is I need to make sure I get these connected to 106. I wasn't paying attention. when I was circuiting in a hurry. Boom. Back to 106. And then the same here. Get that to P106. But you can see how easily that has changed. Okay. Now we have a piece of mechanical equipment here. We're going to say it's the same, but which one is it? It is HRU 107. So let's get an equipment connection for that. I'm going to move this. And now when I hit tag, it's going to remember my last tag I used was this hex. And we're going to call this one duplicate. Don't just change it, but we need to duplicate it, 107. And we want it to show up in equipment schedule. 107. There we go. And we don't have any other units showing up unless they show up on the second floor, which we'll deal with later. Again, this commercial space, they don't show up in this plan view. So that's all circuited. Welcome to episode 3 in this commercial Revit electrical project series. So here we are in our Snowden Towers electrical model. We're on second floor, level 2. And in previous episodes, we've covered the parking level and the first floor level. And first floor was a bit complicated. Luckily, on this floor, we only really have one floor level to worry about. Now, we do have a mezzanine here. This is a little eating area above a cafeteria. And then we have the rest of this plan, which is some apartment units. So let me jump over to the architectural plan so we can get a good overview of what we're looking at with all the room names and everything. So I like to have a PDF set of my architectural set when I'm working on it because you can't see all of this stuff in the model when it's linked in. So we need to take a look at the actual PDF. You can see we have all these other descriptors, things like open to below and things like that. So what we have here is a mezzanine level dining area. Above what's downstairs is a cafeteria. And we worked on this kitchen and the commercial areas here on the last episode. Go back to that if you want to see what we did there. But on this floor, we have that dining area. And of course, the elevator lets out into that. We have some stairwells, 3 of those, and then even a little bit of a stair here. We have now some housing units. We have here a studio unit, Unit 203, which is, again, just a studio with a kitchen and restroom. We have a 2-story studio unit. So this looks like the main floor, and then it goes up with a spiral staircase to a second floor or mezzanine. Here's another elevator that lets out into the what I would call the residential area. And then we have a live-work unit, where this may be where someone may live and have a studio or shop. Now over here, this big X in here typically means that it's open to below. And they actually say it here in this space, open to below. So these are 2-story high spaces. We won't really have much electrical connections. We're doing the power plants up in here unless we have some HVAC systems up in these areas. But that is what we're looking at. And we have one more live work unit here. Now, one note I'd like to point out is that if some of these residential units look identical to each other, we often do a shortcut where we only show the details and build out of one of each of these typical units rather than showing it multiple times. So as we go up the building, we may see, again here, see this studio unit 304 matches 204. We don't need to build this all out again. That's our shortcut that we used. And so you may make those same decisions. Same with this live work unit. If they're the same, we can have a note that says, see the typical unit build out. So we'll cross that bridge when we get to it. We are going to put some panels in these apartment units. There will actually be a load center style of plug on breaker panel, but we'll put those in here as well, and we'll go from there. Now, what I want to show you is if we take a look at the section, and I'll do that in Revit, we can take a look at the section here. I've already got a section cut, so let's jump into that. And it's not set up with any great view filters or anything like that. So it looks kind of messy, but it gets the point across. We have down here our parking level, which we've done. our few levels of level 1, which varies by about 6 feet from low to high. Then we have this M1, which is the mezzanine level, which you can see here has our mezzanine level above the kitchen. And then about between 5, 6, and 8, 1, so about 2.5 feet above that, is level 2. So we have a little bit of difference in these levels. Now we could create a plan view that shows that is set up in this mezzanine for that lower level. And we may actually need to do that. If we have receptacles down in this area here, we may not see those in our plan. So we will have to address that when we get into the power plan. But if we need to, we can create a plan region, a sub-region in here that has its own view range so that we can see our devices. So we'll take a look at that later on as we go. So let's go ahead and get started. Now, one thing I noticed too in my previous plan is I've got 2 sets of grids. And what I did not do yet is turn off the architectural grids. The ones that highlight that I can click are the grids that are in my electrical model that I can move around and have control of. And I can decide if I want the grid bubble to show up down here or not, and I can move them around. I don't need the double grid. So what I need to do is go into my linked architectural model, turn grids off the category in that model. Well, because I'm using a view template, I need to go in here. I can't do it up here under visibility graphics. I go down to the view template, and in my 1/8 inch power plan, I'm going to the Revit links tab. And as you can see here, I have an architectural link and an HVAC link. And so we'll come back to that HVAC link here in a minute. We linked this HVAC model in the previous episode if you want to go back and see how we did that. But we have that in there so that we can connect their equipment. If we go to the architectural and we have it set up as a custom display settings, and the grids are an annotative element, an annotation category. It's set here for custom so we can get to these categories. We want to go down to grids, and we're going to turn the grids off, and we already have the grids off in the architectural. So what that means to me is we need to turn them off in the HVAC. So let's go into custom, to the annotation, set this to custom as well, and we need to turn the grids off here as well. There they are. See, those were on. So it wasn't the architectural that was the issue, it was and they're gone, the mechanical system. Next thing I like to do is jump in and throw in some room tags so we know what these rooms are, so we can tell our builder, our contractor, what these rooms are. So we just go through and do some room tags. Any area that's blue is actually a room, a Revit room that the architect put in. And this will reflect the same room name. So we will just get these labeled. Now, this is the cafe below. I can label that, and I can label the covered dining, the park. Let's get this stair. And here's our studio and our 2-story studio. This is the corridor, so I'm going to put it out here in the middle somewhere. I have another elevator, E2. Live work, this is some commercial retail area. And this is the commercial retail. And this is the residential lobby with the stair coming up. And this guy is our live work unit 202. So, simple as that. We have room names escape out of there. And we can see those, and they are in our model, so we can move them around at will. Now, what you can also see is we have already linked in the HVAC. So this guy here, and I can't click on it because it's in a linked model. I can hover over one of the edges of this and hit tab a few times, and eventually there, it lights up. So it's telling me it's a heat recovery unit, HRU. If I click on it, I can actually get the details of that family that's in the HVAC link. So we can see some information. But we're going to be putting in receptacles and equipment connections and panels. Now this area already has a panel. In the first floor, we can see already we already have a panel K. So this whole sector we are hooking up to panel K. So we can go ahead and use that for this as well. But let's see what we want in here for receptacles. We're going to give receptacles to each of these, and these look like, this is probably a booth, and these are seating. There's probably tables here. We're going to put some receptacles along there. Now, what I can do is go down and grab a receptacle down from my families. My families is open, and I have electrical fixtures open. I've brought in my non-hosted duplex receptacle right here. Duplex receptacle, non-hosted. I can bring this in. Now, I have another video that shows how to create non-hosted models, and I also hope to soon have a whole family of non-hosted models for purchase if you want to take a shortcut. But we're going to go ahead and bring in this standard non-hosted receptacle. And it's going on level 2. It's already set up for 1'6", which is fine. Now, we have to remember that we are actually on the mezzanine, so we will have to adjust this height for the mezzanine. But let's get receptacles put in, and we want to snap as close as we can to that wall. Because it's non-hosted, it won't actually stick to the wall. We have to place it on the wall ourselves. So we're going to put these here. Now, before I go further, I want to adjust the height. So I'm going to take my little section, move it back here. This is just a section I'm using for coordination purposes. I'm going to pull this back, and then I'm going to go back to my section and see if I can see my receptacle on that wall. Let's get to the right place up here. And I don't see it yet, so let me check my view settings. And I'm going to go to view template. I actually have a view template called section electrical distribution, but it has also electrical items. So there we go. And let me turn thin lines on because the scale we're out. There we go. There's my receptacle. And as you can see, it is high. It's up here by this window because level 2 is right there, and it's 1.5 feet above level 2. We needed 1.5 feet above M1. So let's get the exact distance between these two. And from M1 to level 2 is 2'7". So I need to lower this device by 2'7". Or I can even just, get close. I'm about 2'6" away. So if I'm plus 1'6", I need to be minus 1 foot to get it closer. There we go. So that puts it approximately 18 inches above M2. So back to our floor plan. Let's see what we have. And here's our area, and we've lost sight of our receptacle. Now, this is what I was afraid of with the difference in levels. So what we can see in this section is that the receptacle is below level 2. Now, a couple things we can do. We could go to level 2 and we lower the view depth, which lets us look below level 2. And you would do that if you were like on a ground floor and you wanted to see underground conduits, for example. Now, one thing I'd say about that, though, is it changes the line type. It changes the appearance of the devices that are below that level. And we don't want that. So our best solution is to create a plan region for this mezzanine. And this mezzanine goes down some steps. I think if we just leave it at the mezzanine level, we're fine. So we want to do that. From the mezzanine, we're going to change the view range. So let's take a look at second floor. What is the view range already of this view? We go here to view range within our view template. We can see that bottom is associated level, which in this case is L2. Cut plane is 4 feet, and the top is a hard 11'6". It's an actual hard dimension. It's not relative. We need to keep that in mind when we create the top of ours. We could just go up to level 3. So we'll see how that works. But what we want is just a plan region of this area here so that we can see our receptacles. So what we do is we go up to view, and under plan views, down here we have plan region. I have a whole video on how to deal with view range and plan region, which is a very critical thing to understand in Revit. That third dimension can really screw you up if you don't understand how to deal with it. So plan region, and it puts us into an edit mode, sketch mode. So I'm going to use the tool, the rectangle. I'm simply going to rectangle out my mezzanine, and it's going to include the elevator, which is okay. And I'm going to stop about here. We can move this around later. For now, we're just sketching it in. And then for now, I can also say, what do I want that view range to be? I can adjust it now or later. So we bring up the view range, and it gives us absolute levels. The bottom now, we want to drop it down to the M1 and with 0 offset. So the bottom of our view is actually at the mezzanine level. Now the cut plane, we want relative to M1, and 4 feet is a typical cut plane. That's where it's going to cut the walls to help us see our plan. It will also dictate what we can see. Now the top, we can still have the top be relative to level 2 because the top is the same as the rest of the plan. So we can just leave that. We could also change the top to be level 3 with a 0 offset or a -1 inch offset. We can do whatever, but I think for now, let's leave it the same as the rest of this entire floor. And we're not going below M1 for a view depth. We're going to leave it at 0. So let's see what that does for us. Until I click finished, we won't see the results. So let's finish it and see what happens. Let me turn off thin lines. Now, what you see, this big green fat line is the actual plan region boundary that I have bumped up in my view so that we can see them. It's typically a tiny little thin green line. Now, this doesn't get plotted or printed to PDF or anything like that. So it's just for an aid for us. But I like to highlight that because it's hard to see normally. So there, that shows that this area has a different view range. And now I can see my receptacle that's below level 2, and it appears with the right line weight. So now we can move on. This one is already set up with the proper elevation. Even though we have a plan region that affects the view range, we are still putting devices in that are relative to level 2, which is the associated level of this view. So keep that in mind. We've got 2 different things here. So I'm going to just simply right-click, create similar, and what that does is it gives me another one that's -1 foot below L2. It keeps the same height when I create similar, which is handy. So let's do that. We're going to put these in under these chairs, under these benches. Let's just add these. Now I can also just copy these. But I'm going to go ahead, I'm on a roll here. Now this guy will be here. I'm also going to throw one out in here for general use. And then this is all railing along here. So unless I was to throw some kind of floor boxes out here, I could put one on this column. So let me spin that around. I put one here. And what these can be used for is cleaning, or even if you're sitting here, you could, plug a phone charger in there if you like, or hook up your tablet or laptop. Let's go ahead and turn these and put those under these 2. I want to get it right on the wall. So we have kind of a double face. Again, non-hosted, we have to find the wall ourselves. So that seems like that would work out for now. We'll, behind the scenes, we'd be working with our architect and our interior design team to figure out maybe some ideas, and with the owner to see what they want. So that's the basics of that. Now, the other piece we need in here is we have this mechanical unit that we looked at, and let's go ahead and tab over it again. It is named HRU 200A. So there must be, there's 2 of them in this 200 area. So let's go ahead and get that hooked up. So I'm going to connect this with my custom motor connection. So if we go down here to my families, and I've used this on the previous episodes, down here, ER, which means it's my custom electric rod version, motor connection. And you can see I have other HRUs already in here. We need a separate type for each connection because they could have different electrical characteristics and they have different mark numbers. So let's go ahead and take one of these in, HRU 107, bring it in, and it's a motor and disconnect symbol. And it's just a 2-dimensional symbol that has an electrical connection. And again, this is just a custom family. I have a video that shows how I create this. If you want to make your own, I'll link that in the description below. But it has some settings here. I can unfuse it by clicking off the fused and just leave it with a disconnect. I could even turn the disconnect off if I don't need it. And then the type parameters of this are a load classification, which I set to HVAC, single phase or 3-phase, and now it could even be 2-phase, which in Revit language is a 208 single phase connection with 2 poles. But we have set these up as 3-phase, and we only gave them a motor load of 3 kVA. This little guy here, equip, is a flag that I put under type comments that tells my mechanical equipment connection schedule to let this piece of equipment show. And I'll show you that here in a minute. And then the type mark that I'm using with my tag is here. So I need to duplicate this and make a new type called HRU 200A. Again, anytime you have something different in your type parameters, you need to create a separate type. So duplicate it and create your own. And I need to retell it to go to my kitchen equipment, to go to my equipment schedule. And as you notice, I also can put it on a kitchen schedule. I show that in previous episodes if you want to check that out. And then again, this is what I'm going to use for my tag. Now, some people use the type as a tag, and some people use a type mark. I use type mark because sometimes I want the type to say something different than I want in my actual tag. But that's also very customizable. 200A. And then what I can do now is I can go up to tag by category, and I have my equipment connections set up, or fixtures set up, to show this kind of symbol, hex symbol around the name. And that's what I use to tag it. And I can make this arrow end, I can make it a free end. Right now it's attached end on this leader. I can also make it float with a free end. It gives me a grip that I can move around and point to that if I want. I can also put a little shoulder down here like that. But that's how I hook that guy up. Now let's look at this other piece of equipment down here and tab over it, highlight it. It's HRU 200B. So that's the other one. And let's go ahead, and I'm just going to right click this and say create similar. Put this here. Now some people get picky about where they show this disconnect. I mean, this is only a 2-dimensional object. I'm not trying to absolutely show where this disconnect goes on this unit. Again, if I had fixture cut sheets for this unit, I could take a look at it, see where the disconnect should be, where the connection point is. For our purposes, I don't get to that level. That's something that the contractor can detail out in the field. So, because, you know, this is just a basis of design unit anyway. It could end up being a different unit, and the connection point may be a different place. Anyway, just that's my speech on connections. So I'll try to get it close. This is diagrammatic. And then I need to create another type. So duplicate this one, and let's call it B. Revit tries to create the next one, but fails there. And we want this to be on the equipment schedule, and we want it to have type mark as the same, 200B. Okay, there. And let's get that tagged like that. And then I like the free end. And get a little bend to that. Just my personal preference on how it looks. So that's all we need for this sector of this floor. Let's go ahead and take a look at that equipment schedule. I've covered this in the previous episodes, but let's take a look again. So up here under schedules, we have the kitchen equipment schedule. Well, we need one for a mechanical equipment schedule. We could start with the kitchen equipment schedule and modify it for our mechanical equipment. So let's go ahead and duplicate this. Make a copy. There we go. Now we're going to call this mechanical equipment schedule. And it means mechanical equipment connection schedule. So we can say connection just to help delineate it from, you know, the HVAC designers will have an actual schedule of the mechanical equipment. And we can do the same here with our kitchen. Let's go ahead and do that. Make this title nice and long. All right, so let's double click mechanical equipment schedule, and there it is. Now, as a review, what we have is, and you can go back to the previous episode, or I even have a separate video where I show how to create this kind of equipment schedule. This schedule is drawing data from the model. I've not typed any of this stuff in here separate except for this feeder. This feeder here is just text that I type in. The rest of this is drawn from the families in the model. Now, some of this I can change here, which actually changes it in both places. So just remember that a schedule is very powerful in that it reflects information from the model, and it's a two-way street here. Now, this one, we don't want to show kitchen equipment. We want to show mechanical equipment. Well, how do we deal with that? What we did on this, or if we go over here to the filter, there's a filter setting. What we've done to filter what shows up in this schedule is we've looked at that type comments section. You recall we have the type comments in our mechanical unit. So if we go to this guy, edit type, type comments is a parameter that we have set to say equip. That's something I made up. And then this schedule looks at that type comment, and it says if it equals kitchen, then we want to show it in our kitchen schedule. Well, we're making a mechanical equipment schedule, so we want it to equal the other flag, equip. Now, if it says equip, it shows up in this plan, and simple as that, there we go. Everything else is the same. So it shows the electrical data for the equipment for each unit. It even shows if it's connected to a panel and circuit. Now, the first floor I've already connected. It looks like it did not connect 107 yet, so we'll need to go connect that. But all the connections and everything shows. And I haven't typed in descriptions. I can type a description in here and just call this heat recovery unit, HRU. Now it says this change will be applied to all the elements of this type, HRU 105, which is fine. It's a type parameter. You'll get this warning every time you change a type parameter. And there. Now, if I go back to HRU 105, you'll see that that's changed in that. So let's go ahead and change ours. Now you might think I have to type this in again. Well, luckily you get a drop down. Heat recovery unit. Okay, same here. Go down to heat recovery unit. Okay. I've changed the description for these. Now if I go back to look at my 200A and B, click on this, edit type, right there, description. It changed it in both. So these dialogues are just looking behind the scenes at a database of all this information. So that's one of the powerful things about the Revit software is that it's reading its database and we don't have to type in a bunch of things a bunch of different times. And with the associated errors that can happen. So that's equipment connections and that's the schedule. And eventually we will go in and type in some feeder sizes, which I use a feeder schedule, a text-based feeder schedule that will tell them what the 20-2 means. It means it's a half-inch conduit with two number 12s and a number 12 ground. So I use a schedule-based. So back to our floor plan. Now what we want to do here is we can circuit these. In this series, I'm actually going beyond just schematic design or design development. I'm going to actually show getting into what I call CDs or construction documents that we are showing devices and circuiting them as we go, rather than a separate phase later. So we want to circuit these and we're going to keep them in panel K, which is below. And we saw that. So let's go ahead and circuit some receptacles. Now, these are design-based decisions on how many receptacles you want connected to a circuit. You follow NEC rules. There's also just rules of thumb, things like that. These are all set up. Let's make sure they're set up properly. 120 volts, 180 VA, and we have them in a receptacle. That looks like what we want. So what I'm going to do is, the order I do things is I like to take one and hit the power button to connect it. Find my panel. There's K. And so that's connected to panel K. Over here, panel K, and it assigned circuit 37, which was the next available circuit. And it put it in the order that I already set up to go down the odds first and then down the evens. If you think of a panel schedule as odds left, evens right. Now, I could just end this and say I'm done. But what I like to do now that I have one connected is hit edit circuit. And then it automatically says add to circuit. Now I'm going to add some more. And one thing you can tell is the ones that are not on my circuit are kind of grayed out. So it makes it easy to pick them and see. Now also you'll notice that it won't let me pick anything else. I can't pick even a tag because I'm in circuiting mode where it only lets me pick. So it kind of helps with selection. I can only, if I'm way out here, I would start picking up other items that are out here if I had notes and tags. So this way I can just pick these. So let's put these 4 on a circuit. So I'm done circuiting those. Well, nothing looks different. So what I need to do is tab over this, hover over one of these, hit tab until I see the dashed circuiting. Click on it. Now I have selected the electrical circuit. Again, like we've done on the previous episodes, we're going to add arc wire. And you can have wire or not, it's up to you. And I have a whole video on how this wiring works. Recall that we are drawing conduits or cables, not just wires. There's wires inside here. But what we are showing is the actual cable, or in this case, with a commercial project, we've got MC cable or conduit system. So I've got that routed. You can use the grips to move things around and change the arc. We can see that we have a ground, a neutral, and a hot in this home run. That's all set up behind the scenes in our template. And then we want to tag it. Now, do we want a leader on that tag? We don't, so I'm going to uncheck the leader. And I have this set up to tag home runs with a panel dash circuit number, as you can see there. Again, that's all customizable. And I have videos that you can check out to see how to do that. Simple as that. Now I can go to my next ones and go here, and let's power it up. Panel K, it remembers, so we're good there. And it picked the next odd number, which is 39. I'm going to edit circuit, add the rest by default. And here we go, adding the rest of these receptacles. Finish editing the circuit, tab, get to the circuit, and hit the arc wire. Voila. We have that. Now we can change where this hits. I can put it over here. I can get my arc going like this. So I can make it look somewhat pretty. I get picky about how these look sometimes, probably too picky. Let's go with that. And some people just put K39 by each receptacle. And you can do that as well. And I have videos on my channel that show how you can create a tag that just tags each receptacle with its circuit, and you don't need the arcs. So you can do this however you like to. It varies firm to firm. Let's do one more. Circuit these guys. Power, same thing. Edit. Let's add these. Finish it. Tab over it. Hit the arc wire. And it's putting an arrow, home run arrow, at the point closest to the panel, which is below. Now, also in my wiring video, I talk about the voltage drop calcs and the circuit path editing, things like that. I'll put a link to that video in the description. And just to indicate that when it comes to voltage drop calcs, Revit is not great. And most people that I know either do their own voltage drop calcs still with an Excel or Docs spreadsheet. And there's third-party programs out there that will help you with voltage drop calcs. So check out that video to see what's going on there. Let's go ahead and add this. I'm close enough to my panel here where I'm not worried about any voltage drop issues with these short branch circuits. So there I have those connected. Now let's connect these mechanical units. Same idea. Click on the mechanical connection point, hit power. The panels, by the way, that show up here in this drop-down are only panels that have the same voltage characteristics as what I'm connecting. If I had this set up as 480 volt, these 208 panels wouldn't show up. So if you don't have panels showing up, then you have a mismatch between your voltage or even phase settings. I have videos, of course, on how to deal with that whole setup and distribution systems. So we're going to connect it also to panel K. It's already connected. And now it's connected at 2, 2, 4, and 6. It knows it's a 3-phase connection, so it's done that automatically. And that's the only thing I want on that circuit. So I'm just going to say, go ahead and arc it. Now, because I have an equipment schedule, I don't really need to call out what circuit it's going to, what panel, and all that. That's why I have an equipment schedule. However, I like to see a home run on here, at least to show the panel and circuit. If it's not too crowded, I don't mind showing it. And I'm not worried about the home run here being different than the mechanical equipment schedule or even the panel schedule, because they are all drawing their information from the same database. So I don't have the issue of mismatch like you did back in CAD days if you were doing things like that. So I don't mind showing this here. Now the wire size and all that will be taken care of in that equipment schedule with that feeder tag. But at least here, I think it's helpful to see where this is going. Again, this guy gets connected, power, arc wire, and we can move that around to show it how we like. And let's go ahead and do this. Now it's showing it as a 4-wire home run. I may only need 3. It's just a hazard of Revit adds that neutral in there. Now I can go here and hit plus and minus to add more hots or reduce the number of hots, but I can't change the neutral. So we're just going to be stuck with the neutral. Again, my feeder schedule will dictate how many wires it actually gets. So we can actually turn those ticks off in home runs if we want, but I'll leave them on for now. So we are done with that sector of this plan. Now we'll move on to the rest of this level. And let's take a look first. We have some corridor spaces. Now this here, let me right click and do create similar. And see, this area is white. It doesn't even have a room name. So this may be called something else. We don't know. It's just going by the last. See, the last one I was in it just hangs in there. So we don't know what that is. I'm going to go ahead and say it's part of the corridor. And typically you'll want receptacles in your corridors for cleaning. So let's go ahead and do that. Now, do I want to copy this receptacle? I don't, because it's set at a height for this mezzanine. So let's go ahead and start with a new receptacle. Now, I could go down here and just copy one of these receptacles. And let's check that one. See, it's 1'6" above its level. So I could just say, create similar, pop it up to my second floor and go from there. And it will change to my current level, which is nice. So let's go ahead and put this over on this wall. And then in my corridor, I typically like to, I maybe have like 50 feet between receptacles. Again, these are design decisions. So what's our length? We can go up here to this little align dimension, and then we can click on pieces of the model, or even the architectural link, and just see how long that corridor is. It's 87 feet. So I'll want 2 receptacles in here. So let's right click here, create similar, and I want these about 50 feet apart. So I'm going to put one here, and then down here, let's go ahead and get one about here. Again, you would normally talk with your architect and interiors folks and figure out exactly what you want there. Now, the residential lobby is just stairs coming up, and we are in the 2nd floor. So I'm going to put my own little note here, something like all caps open to below, just to help our electrical folks know what's going on. And I can actually copy this note from here to here. And then also we have another one here to show that these are all the 2nd story. Now we will have some mechanical units to deal with here. So let's take a look at this commercial retail space. Hover over this, see what this is. It is HRU 108A. And I'm going to figure that that is 108B. There we go. So let's get some equipment connections here. We can right click this guy, create similar, and then go down here. Now I could turn this if I want. If I knew exactly where this is, I can do that. So I'll go ahead and do it here just for example, but in reality, it's not going to matter much in my situation. So again, what was this called? This was called 108A. So we want to duplicate this, HRU 108A. And we're saying these are all the same. What I reviewed in previous episodes is we have PDFs of this mechanical, but we don't have the equipment schedule. We don't know the VA of these units. So we've made an assumption. We want to make sure this is on the equipment schedule, and we want to call this HRU 108A. And we'll do the same here. 108B. Same thing over and over. As you know, doing electrical design, there's a lot of repetition, especially as we get into some of these apartment units. And I must say, try doing a 30-story apartment, and it can drive you bonkers someday with the repetition that's involved. Okay, let's go ahead and tag these. And this time we do want a leader. So if we don't want the leader, we can just say no leader. What happens if we put it in without the leader? Well, what we can do is we can add the leader now. So once it's not up here, but over here now, we can say add the leader line. So you can add the leader once it's already in. And then I want to free end this. There's no way to make that free end stick to every one of these. We have to, I'll just point it to the disconnect. And then let's right click. We can just do a create similar for this guy. And let's say we're going to put that one down here. And we're going to add the leader. And it is free end. What happened to it? There he is. And you can put these wherever you like. Now we need to circuit this. Now let's see what circuit we have in Commercial Retail 108. Over here, and what we learned in our previous episode is that because these are on different floor levels, different levels of level 1 even, we have 3 different sectors. So we need to go to first floor plan block 37. We need 108. Here's 108. And what we had done in 108 is we'd put a panel in, separate panel P108, a 12208 three-phase panel. So we are going to get to panel 108. So let's go back to our second floor. These guys get connected to 108. So let's start with A, power, to now P108. There it is. Simple as that. It assigns the next available 3-phase circuits, arc wire it, and I can move this connection point and then tag it without a leader. And it puts the panel dash, the 3 phases are listed. And we'll do the same with this one. Power, let's arc wire and move things around a little bit because I'm picky, and get this up here. Remind you that we can jump into these panel schedules and move things around. Once they're connected, it automatically connects them to these circuits. So I can't tell them what circuits I want when I connect it, but I can quite easily move things around. So that's the workflow with Revit circuits. So if I wanted HVAC units to start over here, for example, on the right side of this, I could simply take that, move it to, and it gives me some green areas where I can move it right there. So I can easily move these around. So don't worry about it automatically doing that. Now, also I need to review my circuit breaker sizes, and I'm okay with 20 amps on these, but if these were larger, I could just type this in and put a 30 or 50, whatever it is. So that's how I can change these. You can also change it in the actual floor plan view. If I hover over the circuit itself till I get a dashed line, now I could go into the rating and frame size of this breaker that's feeding. So I can change it here as well. Now, another thing I failed to do so far is change the load name. Instead of just HVAC, which happens to be the load classification, I want to actually change the load name to display on the panel to let them know what that circuit serves. So for example, I want to tell them that this serves HRU 108A. Apply that. And I want this one, hover over it, select it. I want this to be HRU 108B. Apply that. Now, if I go back to that panel schedule, which I can get to from here, now it doesn't just say HVAC, it says the actual unit. So we want to make sure we put something descriptive in to each of these. So, and it's easiest to do it in that plan view rather than from this view, because when I'm in this view, I may forget what that circuit serves. Another thing is, if you click on this panel schedule and I want to find where is HRU 108, I can go back to my plan views and try to find it. Now, it showed part of it. There's the 108 part, but where's the rest of it? So I need to go around to my plans And there it highlighted it in blue. So if you're trying to find some connections, that's a nice way to do it too, is click on the circuit in the panel and it will highlight it for you in your plan view. So just some little tips and tricks as we go. And before we go any further on this, I want to point out that there's another way we can do this two-story space. I work with some clients that prefer to have a space like this all on one level. For example, there's no floor between first and second floor of this commercial retail. It's just 2 stories tall. So to have the power broken up into 2 different plans is a little awkward for their installers. So what they would want me to do is go back down to first floor, and this would be in block 37, and show those connections here on this one plan of the entire space. But because this isn't tall enough in here, the view range isn't high enough, we can't see those. So I'm going to show you the example of how to deal with that. So again, second floor is where it shows, but we want to show it on first floor. So let me show you how we can do this. We need to again do a plan region. And we're going from, let's see, grid C in between 6 and 8. So here's 6 and 8. 6 and 8, we know that. And we need to go up to grid C. So we're going to create a plan region again so that we can change the view range. Plan region, and we are going to go rectangle again from here, grid C, down to the front of our store on that grid 8. Now, how high do we want to go? Well, we want to go from this bottom L137 up to, we want the top now to go clear up to level 3, and maybe just, I'd like to lower it like 6 inches below so that I don't get floor boxes, for example, that may be in level 3. Apply it and say, okay, and then go ahead here and check mark. And what we do notice is that now we do see our equipment connections that were up high. Now I don't see the mechanical unit up there, so we will have to see what's going on with that. We want to be able to see these. Let's see if we can tell how high these are. These are up at 18 foot 8 above level 1. So let's make sure we're up at least 18 foot 8. We may need to redo this to an absolute. So let's go with top at block 37 to maybe 19 feet. There we go. So now we can see those units. And we can continue on with our circuiting. So what would happen up here is we don't need all of our circuiting shown here. So we're going to get rid of these, just delete them. And then we also want to apply a view range to this space as well so that we don't see this. We want to increase the view range, the height of the view range down below, and decrease the height of the view range here so that we don't see these elements. And we could also manually go in here, hover over them like that. If I right click on that, I can say hide in view element, and it hides it. That's another way that you can do a one-off, or in this case maybe 4-off hiding of things in a view. Now you do that, well, how do you find it again if you do need it? Well, down here at the bottom, there's this little light bulb, and it says reveal hidden elements. That's a trick where you can click on there, and depending on the size, it'll take a second, but it's showing the things that are turned off by category or they're hidden in elements. This is even showing things like the origin points and the survey point. It's showing lighting. It's showing all these things that are actually turned off in this plan. So this is a nice way that you can find some things that maybe are hidden. So if you ever want to go back and turn this back on, that's how you would do it. And you could just hover over it and right click and say unhide in view the element. And that puts it back to normal. Then just click on the light bulb again to turn that off. So let's go ahead and try the plan region. It's a good practice to learn how to do these plan regions, because this frankly stumbles a lot of people on Revit projects dealing with this third dimension. So it's good practice. We're going to do it there, and we're going to make the view range from this level 2, and we're going to make the cut plane at like 1 foot, and the top is going to be at 2 feet. Apply it and check it. There. Why do we see these? Well, we see these because they are actually installed at level 0 elevation. They're a two-dimensional object, but they're actually in the model. They're not an annotation. So these things end up being down at 0. So there's a trick to this view range that we need to make the bottom 1 foot above the floor. There we go. So there's a trick, a way to hide something by view range intentionally. Usually it happens by accident. So there's that way, or you could just do the hide elements. But so this is a way that we can get those shown down below. And then here we can go ahead and do our tags, because as we know, tags are an annotative element that only shows up in this view that we put them in. So we can do this, and we can do another one, and then we can do the circuiting, tab over the circuit, arc wire, and do this just like we did before. Let's do it over here, arc wire, get that moved up, and then we can do our tag without leader to these home runs, like we did before. But now it's down here with the rest of the electrical, the receptacles, and everything all in this one floor. So I wanted to point that out. That comes up now and then. So back to second floor. We've already done this. Now, what about this one? This commercial retail also. So let's click on that. As you can see, this is just a portion of that level 1 that was at a higher floor level. So in here, now is this whole space, except for the stairs, this whole space is up high. So we need to do a plan region for this whole commercial retail space. And we'll probably do the same 19 feet. Now we have to remember though that we do want the restrooms to show. We want the cut line to happen in these restrooms. Let's go to plan region. I'm going to stay outside the restrooms for now. Let's see how that works. So I need to actually sketch a boundary. And I can stay in the middle of these walls. And I can go down to here. Again, I can modify this once I've already drawn it. Here. And then I want to stay kind of in the middle of this restroom. We will see. When I get up to here, it looks like I intersect properly, so do that. Now I didn't change the view range yet, so let's go ahead and do that now. Edit view range. We want to go from this block at 4 feet, and the top now is going to be, we decided 19 feet. So we're just raising the roof. So it looks like, because this boundary does cut through this mechanical unit, that it shows up without affecting how our restroom looks. And then I need to, of course, redo some of this so that it's not in the way. We can do something like this, get that GFCI, and we just move things around to make it look right. Now I can connect these two units up properly. Let's see what they are. Tab. This is HRU 109B, and this is 109A, I would assume. Get down here and do it right. There we go. 109A. All right, so let's do that. We will get the connection from here, create similar, hit spacebar to rotate it to 109A, just like we did before. Duplicate it, 109A. We want it to show up in our equipment schedule. Oops, wrong one. Show up in our equipment schedule, and There's 109A. And let's give that a tag with a leader. And the same thing up here. If we show that over here, 109B, duplicate it. Equip it, and 109B, and tag it over and over again. There we go. And that's too close. Let's move this out a little bit. There we go. And then we need to circuit these. So we're going to circuit this one to 109, panel 109, power it to panel P109. And we want to call this HRU 109A. This is one place where we do have to retype things, is in load names of panels. The default is just the load classification, or sometimes it'll bring in the room name. So we do have to type it in there. And let's get a home run on here without leader and a tag. We'll get a tag on there without leader. And same thing here. Let's get this guy connected. Power it up. HRU 1099B, if I can type. And then arc it. And tag the home run. Now that gets a little crazy. I'm going to go ahead and move this down here, and it's going to move my tag, but that's okay. This guy, and I can move. Here's the point. Again, if you can't see that point, hit thin lines, and then you'll be able to see that point much better. Now you can see this tag moves around as I move that arrow. So I just need to bring it back up in here. Something like that. So now things are all circuited there for that second floor plan. Now we need to again fix this so it doesn't show. This one I'm just going to do a different method just to demonstrate that I can put hide and view the element and hide and view the element. There we go. So a couple different ways that we can hide those. So now to the rest of this floor, these corridor receptacles we put in, we need to connect those somewhere. So we can either have a panel on this floor that serves the common spaces, but frankly, we're talking one circuit and maybe eventually one lighting circuit. It's not worth a whole panel. What typically can happen on a project like this is the common spaces will be powered by maybe a panel on every other floor, every third floor, or even all from the first floor if it's not super tall. We also have to consider that the lighting in this corridor will be on an emergency backup of some kind, so it won't even connect to this normal panel. So we will connect this up to a panel that we have down on the first level. So we can go look at that, and actually it's in the parking level is where our main electrical room is down here. So we have a house panel down here, HDP. We can connect it to that just like we did the rest of these. So let's just go take those down to HDP. So back up to our second floor power plan. We're going to connect these receptacles. And again, I just connect one first, power it up to HDP. And I'm going to call this receptacle. And this is going to be corridor, second floor corridor. I don't use room numbers typically because, they don't show up in the real world when you're out walking this building. There's no sign that says you're in corridor 201. So it really doesn't make sense. Now, an apartment unit may be different because this may have a unit 203 badge on it. So that makes sense. But when I'm referencing for panel schedules, I like to have some kind of a real world descriptive name for the end users to relate to, and any future electricians that come in here. So let's go ahead and edit that circuit by adding more. So let's add the rest of these two guys and finish editing. And then let's go ahead and get an arc in here. And of course, I put the arc here because our panel is down underneath here. So let's go ahead and modify some of this circuiting. So now let's look at what we need to do for the rest of this floor. We need to connect some residential style dwelling units, these apartments. Now these are going to have their own load center type panel in them. Now there's a couple different ways that this can be done. First of all, if we just use a panel board, a Revit panel board in here, and start connecting circuits, the calculations that get done are commercial calculations. They're based upon 180 VA per receptacle. They're adding up nameplates for equipment. It's commercial demand factors. So it doesn't lend itself to dwelling units. So if you look in the NEC, it's a whole different way to calculate things. In fact, it's a whole different way to calculate multiple dwelling units connected to one distribution board or one meter center. So we can't use our standard built-in calculations with Revit. There's a few ways around this. I've seen some people go through and customize a panel schedule with custom formulas and things like that, custom load classifications to help do those calculations. What we use in our firm is a room-based calculation in a separate load center connection, which I'll show you. Then we use a special annotation that does the actual room-based calcs. So what we use in our firm is, I'll show you, is a load center connection that we customized. And let's go down here to electrical. It's actually a fixture. It's not a equipment. It's not a panel board. It is just a connection. So you'll see here, ER load center connection. And we already have a basic in here called Studio Panel, so we can bring that one in. And it actually is face-based, so it needs to mount to a wall. It's one of the few hosted items I actually use anymore. So we want to put this guy on a wall. I'm going to say it's going to go on this wall right here, this end wall near the kitchen where all the loads are. So you put that there. It's a little recessed panel. And it's at 5 feet to the top. Maybe we can go a little bit higher for that. So what it has is an instance parameter of the dwelling unit area, because that will vary room to room. This is a studio, but they both have different square footage. So it needs to be an instance variable. Now here's where the magic is. If you go to edit type, you will see in here, we have parameters for all of the residential loads. So cooking load would be a range, and it's usually 8 to 10 kW. So we put a 9 kW. A dishwasher, we average, something like 500. The same with a disposal. That's probably too much, and we put in the disposal. The dryer, clothes dryer, we put in kind of a standard code load for that. Now heating or cooling, we need to make sure we get that put in properly. So as we look at the unit, it'll probably be that unit hanging from the ceiling that's in there, HRU. Kitchen is 2 kitchen circuits, and this is all per the NEC calculations. Laundry is required to have a 1500 watt laundry circuit. The microwave is around 1500 watts. Any other motors, like a little exhaust fan in the bathroom, things like that. Maybe a hood fan over the range. And then if we have water heating built in, if we don't have central water heating, that gets in here. And this is set up for 208, 2 poles. We don't have a 240 volt system here because we're on a commercial 208 system. And the load classification is dwelling unit. So this will show up as an equipment connection on the distribution panel or meter center that we feed it from as a dwelling unit, and it will apply the proper calculations to the connected load of all the dwelling units. So these are just connected loads. There's no calculations here with diversity. That happens in another place, which I'll show you. But we need connected loads for our service calcs and our distribution or meter center calcs. So that's what this does. So I'm going to say, okay, and I say we put a separate type for each kind of unit because studios typically have one set of heating, and a 1-bedroom would have usually more heating, 2-bedroom, more heating, etc. So that's why we have separate types for different types of rooms. But for different square footage of studios, that gets handled by this instance parameter. Now, how can we figure out the square footage of this studio unit? One way is you can go click on the room name and room tag, and the built-in room tag has a room tag with area option, another type. Click on that, and there we go. 593. Now you can see the red line. It pretty much stayed there. It even took out one little bit of that wall. But I mean, it's close enough. We can even say 600 square feet if we want to be conservative. So there, 600 square feet is that unit. And then we can go back and put this back to the normal. Or you can just leave it on. You know, I don't have a problem just leaving that on there if I have room. So 600 square feet. So what I'm going to do is click on here, put 600, enter. And you can see that the connected load, again, this is not diversified, is 30,400 VA at 146 amps. Now, again, when we diversify this with our separate spreadsheet type connection, it will lower that down, most likely to below 100 amps. And then I like to tag this with a leader. And it's a question mark right now because I did not fill in the type mark. This is kind of, again, this is just equipment connection. It's not a panel board. So we're going to call this Studio Panel. And I say panel, even though it's a load center, it seems to make more sense to the end user that that's just a circuit breaker panel. So there, that's that. And we're going to need one of these in every single apartment unit. So I do show these in every unit, even if I have some typical units. So let's get these installed in every unit. And we're going to circuit these panels and load centers later when we start adding some more distribution gear. But create similar. I need to find a wall. And I've worked with the architect and the interior designers, and we've decided we want this thing right here. Now I need to tab to get to the right height of this wall. There it is. And this is my love of hosted elements right there. Is that fight that we have. Tab, there it is. Boom, okay. I do need to create an unhosted load center. I can see that. So there is that one. Now let's see what the square footage of this studio is. It's the same. Now it's the same on the first floor, although we have a 2-story studio unit. So we need to take the second floor of this unit into consideration along with it. So how do we get to that? That's going to be up on the next level, 3rd floor plan. This guy here, and let's go ahead, we're jumping ahead, but let's go ahead and get a room name, room tag in here so we know it's the same unit. There we go. So as we can see, it's not a full 2nd story, it only has kind of a mezzanine. So how do we figure out the square footage of this mezzanine? If we do it here, we're going to get the entire room again. So we don't want that. Let's undo that. We just want this portion. Well, what we can use is a region here called a filled region. If we click on that, it puts us into edit or sketch mode. We can trace this 2nd story, this mezzanine, to get an idea of the square foot. So I just use the line tool, and I'm just going to roughly sketch it. Just use some lines and approximate how big this thing is. There. Now it's a filled in region, but over here it says area is 282 square feet. So we've got 280 plus our 600, so we have 880 square feet. And I don't need to save this region, I can just delete it. But 882, let's remember that. 882, and go down to 2nd floor and put that in here. 882. Now it's only changing this one panel, this one load center, because it's an instance parameter. And again, we'll tag this with Studio Panel. Do it like that. So let's look at the next room here. We have a live work unit, and it looks like it's a single level. And it looks like it's only going to have one HVAC unit in it. So we can say that this is like a studio as well. So we are going to put this guy over here. Create similar. And where do we want that? We're going to put that here by the oven. Right there. And the square footage on this will be 1105. So click on here, 1105. Enter, apply it. There we go. And it's still a studio, so I think studio panel works. And then we have another livework unit down here. I was going to say this one looks very much like just a rotated image of that, but it's got a different shape. Look at this. It is a totally different unit and probably has a different square footage. 839. Yes, it's smaller. Let's go ahead and get that load center in here, down here by the range. There it goes. You can do it. Right there. Okay, studio panel. That is the load centers for these. Again, we'll connect these up to a meter center and all that when we get further along. But we need to actually show some build out of these typical rooms. Now, should I do it right here on this plan? Well, you can, and then you could do some kind of a circle it and put a note that says typical for, 600 square foot studio unit. And that would be typical for the one above, because if we look on third floor, it's the same thing. What we have decided to do, which a lot of architects will do as well, is they will take each typical unit, enlarge it to maybe something like 1/4 inch to the foot scale, have it on a separate sheet. They may have the floor plan and the ceiling, reflected ceiling plan separate. We're going to take that approach. We are going to enlarge these and put them on a separate sheet. So I need a separate view for this. Well, how can I get a separate view? What I can do here, and I did it on previous episode, where I enlarged the kitchen area, we use what's called a call out. So if I go to view, here's another kind of view. It's a call out view. Creates, well, this one's a rectangular call out. And a call out's just a place that we circle and say that this is going to be on another sheet. So I'm going to go just outside these walls like that. And I can change this again. This is sketching a rectangle with curved edges. So something like that. And then it's hard to see because it's thin right now, but down here is a little circle. And this little target will actually, and we won't see that green line, this little target will fill in with the actual sheet and detail number that this ends up on when we drag an enlarged view onto a sheet. Now what this did is it created another view over here. Look at this, second floor plan power call out 1. That's the separate view that it created of this room. So if I was to double click on that, there it is. Now there's a couple things I want to do here. First, I want a different scale. Now because I still have my view template here in the bottom right of power plan 1/8 inch, I need to change that. So now I need a separate view template. And remember, view templates are very important. I want it to be a 1/4 inch. So I can just make this a power plan 1/4 inch. Right here. And that's what we used for our kitchen before. So let's just make this a power plan 1/4 inch. There we go. And we see all the annotations shrunk because this is actually a larger plan. Now, we don't really need grids in an enlarged plan because this is going to be a typical unit. You don't need to identify where in the building it is because it's in multiple places. So we're going to turn the grids off. Now that's why we actually need to create a separate kind of view template for our units. If we turn the grids off in this plan, I'm going to be turning the grids off in my enlarged other plans, like my kitchen. And I want grids there because that's not a typical. So what I'm going to do is I'm going to duplicate this. Now if I just hit duplicate, I get a blank name. Well, I don't want to have to type all this in. I'm lazy. So I'm going to go to first, rename, and go ahead and copy that name, get out of there. Now I go to duplicate and I can paste this in, right click paste or Control V in Windows. I'm going to call this unit power plan 1/4 inch. So it's a different view template, still the same scale, but I want to override my annotation to turn off the grids. Go down to G. Here we go, grids. Okay, it turns off my grids. And I don't need this section visible, so what I'm going to do is just hide this element here. So there we have our enlarged plan. Now, do I want a room tag in it? No, because it would put a room name on it, and this is going to be typical. So what we have is we can see our load center, so I'm going to go ahead and tag that again, studio panel. I do want to get some connections in here. If we don't know what all this stuff is, we can go to the architectural plan and see if they have any information about what this is. We can kind of tell by the symbols that this is a range and this is the dishwasher. This is most likely refrigerator, and we can also tab over these things until we get to it. And tall cabinet, double door with glass. So that's a cabinet. So, it makes you wonder, where is the refrigerator in this place? So let's go and see what the architects say about this. So over here, I have an architecture plan. And there's the studio. Do we have, I'm looking for something like this. This symbol here is elevation symbol. And I don't see that in this studio unit. They've not elevated this kitchen. The power of Revit is I can actually just do that myself. So here we go. I find that interior elevations get a little wonky. So I'm just going to use this section. And let's just drag it across here. Now, how deep do I want this section to go? Here's how deep it is. I just want to go to the wall. I don't need to see into the restroom. Double click on this and see what I get. Now, it's going to give me the full height of the building. And I want to narrow that down for my purposes, just so it's not hard to draw. Let's go down to level 2. There we go. Level 2. Okay, so the refrigerator looks like it's right here. And here's the stove. Now, I think the dishwasher is here. And I can tab. There we go, dishwasher. I can tab till I hit, oops, that's too much. Hit just that, and that's the refrigerator. Here's our cabinet. And then you can see in this elevation, I have my lights that I put in another video. So let's go back to our second, I'm going to get rid of third floor plan. Let's go back to second floor plan. And the refrigerator is right here. So we're going to start showing some receptacles for this stuff in here. Now we can just use our standard receptacle with 180 VA. We are not actually going to circuit these to the load center. They are just going to be symbols to show the installers that we need receptacles. So let's go to duplex receptacle. I have my non-hosted receptacle again that we used earlier. Standard. We're going to put one, a space, one here for the refrigerator. I want one here for the dishwasher. Now which surface I put it on. And now we don't know if we have a disposal or not. I'm going to assume that we do. Now that's under counter stuff. Now we also need above counter. Remember, this is above the counter. We need receptacle above the backsplash here. And on the other side of the sink, you need here for sure. And then the other side of the sink, if you look at the NEC rules, you have to have at least a foot of counter space to need a receptacle. Well, between the sink and the oven, this is pretty small. So it's up to you whether we put a receptacle in there or not. It may not be required by code. I'm going to go ahead and throw one in there. Someone could set some small coffee maker or something in here. So we're going to do that. See how this is pretty small? But I want to use my counter. This is actually above counter receptacle, space, for here. So it's a different symbol and it's a different height. And then for the dishwasher between the refrigerator and the sink, I want to center it. So it's going to be probably like right here. So it starts to get kind of busy, even at 1/4 inch. But these are approximate. These aren't dimensioned. And then for the range, we're going to use a 208 single phase or 2-pole connection for the range. Now, what can you use for that? So again, since I'm using my custom content for this project, I have a special receptacle that is loaded. So let's go down to the special receptacle right here. Now it happens to be hosted, another one that I should create a non-hosted for, but it doesn't get used that often. So it's looking for a wall. So let's put it on this back wall right there. You can see it, the joy of hosting as it gets confused in the middle there. So we'll put it like right there. And this is just a special symbol that would be on our symbol list that says this is a special receptacle. And it could have a NEMA rating, but we're going to label it as the range. So what I typically do for this is just throw some text tags. We don't need to be smart tags and all that. We can just use some text tags here. So what I'll do is I'll say something like range 50 amp to give them an idea that it's a 50 amp connection, 50 amp receptacle. And I'll just use a leader and point it down to the range and give it a little shoulder there. Now this one, I will put a text tag on it and say disposal. I've seen some other designers have abbreviations for some of these. If I have room for it, I don't have a problem. Now that section bubble gets in my way a little bit, so I could hide that in this situation. I'll leave it there for now. Disposal, and then the dishwasher. And this one I can just say DW, that typically is descriptive enough. And then the refrigerator, I will typically say something just like refrig. This will be similar to if you're doing any residential type work. You could do something like this. And I have that whole series on my channel about a full residential project, start to finish, that you can watch. So there's refrigerator. Again, we're not circuiting these, we're just showing these. Now, the rest of this ends up being done like a residential dwelling unit. So we have the 6-foot, 12-foot rule, if you're familiar with that. We can't be further than 6 feet away from the end of a wall. We can't be further than 12 feet between the receptacles. And all of those rules, I'll link a good NEC channel in my description below if you want to check out some good coverage of those. And I'm curious what's going on this side wall over here. So I'm going to drop yet another section. Might as well, since we can in Revit. Let's drop a section through here. Treat it like an elevation. And double click that and see what we get for level 2. Just to help narrow down my look. So what we have is pretty much some bookshelves. Bookshelves. This looks like maybe a countertop. So we've got some kind of a bookshelf going on there. Another thing we can do is look at a 3D model of this. One nice way to do that is to maybe surround some devices. And under view up here, you get this little thing called selection box. It isolates the selected elements in the current view, and it creates a 3D isometric view. Right there. Now, it zooms out the entire project, but if I scroll wheel, we can kind of see that it's only taking a portion of this. Now, what's interesting is it puts this blue box in here that is called a section box that I can drag around and enlarge and make smaller my section. Now I want to bring this is the top one. I'm going to bring it down a little bit so I can see inside my room. So there we go. What we're starting to see is this restroom. And if I pull it off to the right, I can see the rest of my room. See that? Start pulling this section box, and there's the arrows. And we're going to make this large enough to see our room. There's the back wall. And here's the other wall. If I go far enough, there we go. Now what I can do is I can use this guy to kind of rotate around, pivot, like that. And I can zoom in and out, and I can see a little better what I've got for bookshelves and countertops. So this is kind of like a desk, built-in desk. Now where you'd put your television, perhaps hang it on the wall here. But this gives us an idea of what's going on there. And then we can also use this view. We can hold down Shift and then use the center mouse button to also pivot or rotate around this view. So now we can get a good idea what's going on in this kitchen. And some of the line types get fat because we have the line style set up for that. So we can go down to get rid of go down to the thin lines, and that sometimes helps it. We've got some of our lights showing up here, so I can lower the ceiling just a smidge. to get rid of those lights. There we go. And again, it gives you a really good idea. And this architect has done a nice job of modeling this room. So there's our receptacles. It looks like they're about at the right height. And again, hold down Shift and hold down your mouse scroll button and you can pivot around. So this gives us a good idea of what's going on here. So what we want to do is get receptacles. We'll probably put one above the counter here, but we're also going to put some underneath because this is considered wall space. Now the wall space is broken by this cabinet, so we only have to be 6 feet away from there. But again, check out that link below to see all these specific dwelling unit receptacle rules. So here's our bookcase, here's our counter and the other bookcase. So we are going to put an above counter, right click on that guy, create similar above here. I still have thin lines on. And then we're going to put regular receptacles below that. So we can click here, and this is the bookshelf. So we're going to get a regular receptacle within 6 feet of that. And I'll put one more down this other end. Now, this is all continuous wall space because these windows don't go to the floor. So this is all considered continuous wall space. Now, while I'm at it, I want to make sure I label this 3D view because otherwise, next time I cut a section box, it will write over this one. So it will always create a 3D view. So I want to title this 3D Studio. And we'll just do that for now so that I can go back to it. For example, I already did the 3D kitchen that you can see here. So if you create a 3D view with a section box, make sure you label it, give it a name, because next time I cut one, it will erase the old one. So I'm just going to show these in here. Normally I would pull out some annotate and some detail lines and I would start measuring dimensions like we have 2'6", and it means I can be up to 9'6" away, something like that. So you can use different ways to lay out your receptacles in a residential unit. Again, it can't be further than 12 feet away. That's 9 feet, so I can be 3 feet away. Let's just say short of 3 feet, right there. And you just go through the rest of this unit doing that. So this one here I can just copy from there. And let's say I go just short of 12 feet to make sure I meet the rule. And then coming in, this is kind of considered probably a hallway, but I like to make sure I get receptacle in here, even if it's a short hallway. So I would most likely put that not on the column. Let's put it on this wall right here. It's close to the panel for wiring. And then in the restroom, we have a washer and dryer, and then we have the sink. I like to put a above counter receptacle typically on a side wall like that rather than a back wall. If you have some ADA accessible units, you also have to look at some of the receptacle placements for that as well. Now, we need a laundry receptacle, and that is going to be here with the washer and dryer. So that is just a standard receptacle. So put that on the back and work with your interiors folks and architect to figure out where the best place for this connection is. Sometimes it's sidewall, but a lot of times the water and waste will be on the side and the electrical will be on the back. But you can get that coordinated if you want, or leave it up to the installer to figure it out, because we may not know which washer and dryer you're getting during design. Now for the dryer, I use another symbol like this for a special receptacle. And that typically ends up being just a 30 amp 208 connection, but that symbol works. So then we can say dryer, 30 amp, and then I can say laundry. And that laundry circuit can be used for the washer. It can be used for plugging in an iron if they can get to it. They may not be able to get to it, so they may have to plug an iron in here or or somewhere else in the unit. The dryer, and then the laundry. Now, one other thing you will typically will want to do is at least state which one of these are going to be GFCI. Now, you also have arc fault circuit breakers, not receptacles, but arc fault circuit breakers in here. And that kind of thing can be indicated on the actual panel, what I call panel directory. It's not a panel schedule in that it doesn't add up loads, but it does provide a directory. And we will get to that in a future episode. And that's where we might indicate that there'll be an arc fault circuit breaker. Also, you may have some tamper resistant receptacle needs. That can be done on a plan, or it can be done in a general note, or even if you have a set of written specifications, written requirements, it can be there. So not everything has to be tagged right here on the plan, but do it the way that your firm does it. And let's get another GFCI. I'm just going to copy this. It's just text. I don't use built-in labels and receptacles because they get turned sideways, and I prefer to have all of my labels up and down as much as I can. And then this guy, it's going to copy over here, and it covers up the DW, but that's okay because I have the dishwasher called out here with my own DW. So something like that is the basics. Now we also have a mechanical unit. Let's see, go back and see what we have for that. Second floor plan. Now they show it here, but I don't see it in my enlarged plan. Now let's go back and see why. Also, we're going to deal with how to not show these in this plan as well. Hang on to the end and we will show you how to turn these off in this reduced plan and only leave them in the enlarged plan. We need to make sure that we call this something else. This call out, we actually want to call this, we have the 100s here. Let's just call it something like, we're going to start with 10 for our enlarged plans. We're going to call this enlarged studio plan power. So we will start our enlarged rooms, units here, 10, 11, 12, and so on. And again, these numbers are just so that things are sorted in a logical order in my project browser. When we drag them onto sheets, we're going to get rid of that 10. So let's go back to the enlarged studio plan, and we need to make sure we have mechanical units turned on in this view template. So down here, we need to go to our Revit link because that mechanical is linked in. Right there, HVAC. Right now it's set up by host view. And that reminds me, we do want to halftone these and underlay these links. So we want to go to a custom view and go to the model, custom the model, and we want to go down and make sure we turn on, we don't want ducts on, but we do want mechanical equipment turned on. You can drag that out if you need to. We do want mechanical equipment to show, okay, so that we can connect it. And it doesn't show yet, so now we need to make sure that we have our view range set up properly for this room. So let's go see where that mechanical unit is to get an idea. We could also cut a section and look how high that is, but let's try this. Let us tab over that, click it, and see that it's up at 9 feet. We need to have the top of our view range at least 9 feet. And just for fun, let's go ahead and take a look at this section again that we did and see how high. So now we're starting to see some of this stuff. So this level goes clear up to 1810 to the next level. So we want to be a little bit below that. Let's just go up to 18 feet and see if that works for us. We want to go up to 18 feet on this. So the associated level, and let's go to 18. Now we could go to just level 3 or next level, thing called level above. We could just go to level above because we know it's level 3, but this way we know it works. So there's our unit, and we want to get this connected. So, and now we go back to our second floor power, and we can find one of these mechanical units like this and just right click, create similar, put it in our studio plan, right here. And now this may not have a number associated with it, or the number may change depending on which unit we're in. So we're just going to call it a generic HRU, and we can just call it unit. Now, the unit ones are going to be smaller. They're typically not a 3-face because we only have a single-face panel. So again, we don't have cut sheets for this, but we're going to say that we do know that they are going to be a 2000 VA system at 208 2-pole. And we're just going to call this HRU unit. We are not going to schedule this. We don't need to put this on the equipment schedule because it's not going to show a circuit or anything like that. We don't need that on the equipment schedule. It would just muddy the waters. So we're going to leave that off of the equipment schedule. But we can tag this HRU unit. And again, this will be accounted for in our load center. And let's check that. We have 3,000 for the heating cooling. Well, it's really only 2,000. So we can fix that. And that will change it in all of the studios. That's the joy of having that as a type parameter. I only have to change it once for all studios. So there, that's the last of the electrical connections for here. Now, if you're doing technology as well, you may want to put some TV outlets, things like that in. We're going to leave that for a separate set of plans. So right now we're just doing electrical. But back to the second floor, I just want to say that we would do the same thing for each of these other units that we want to call typical. And I'm not going to do it here to save time, but that's how you would do it. You would do your call out. And in this case, we'd have to call out, go around the elevator for that guy. In this guy, we'd have to go around this hallway trash room is what that is. But similar idea. And then you would have 4 different typical enlarged studio plans or live work units, whatever they are. So the last piece I want to show you on this that I promised is how to turn off these in this view. I typically don't want it shown twice. Now we're going to do like what we did in a previous episode where I turned off the kitchen. We're going to use a filter. Filters are very powerful for controlling visibility. Some people use work sets. Those have limitations, so I use a filter. Basics of a filter are they act like an exception. Like if you look at if you read the electrical code, you get here's the basic rule and there's some exceptions underneath that modify the basic rule. So same thing here. The basic rule of this view is to show things by category. And that's typically how things are visibility is controlled. For example, visibility graphics overrides. What that means is we're controlling the visibility, whether it's on or off, and we're also controlling some graphical overrides if we want to change the line type or the line style or color. So it's visibility and graphics. We typically turn things on and off by category. But sometimes we need a subdivision of that category. We want electrical fixtures to show up, but not in the units. So how can we pick and choose? Well, that's when a filter comes into play. So what we do is we're in this view template, in this power plan, we're going to put a parameter in each of these unit receptacles and connections that is like a flag that says we only want these to show up in the enlarged view. So what we do is over here under comments, right here, we can say enlarged. Now it's already there because we already have some of those in the kitchen, enlarged. Now if I say enlarged, then that comment can be read by a filter and say if it says enlarged, turn it off in this view. So this is the view that I want to create an exception. I want to say, show all the electrical fixtures unless they say enlarged. So the way we do that, go into the view template and go into filters right here. It's a whole separate tab, filters. Now I already have some filters in here for showing underground wiring and conduit. That's already built in. I need to add another filter in here for the enlarged view. So if I don't have a filter made yet, I need to go to edit or new. I already have one called enlarge. This is a list of all the filters that we could apply to our view. This is a list of the ones that have been applied to this view. So we're going to go into look at all the filters. Enlarged. The way this works, if I click on enlarged, you select what categories that you want to include in this filter. And so what we've included are electrical fixtures, and we can even include lighting devices and lighting fixtures for when we start doing lighting plans. I don't want to include equipment because I want my electrical equipment to show up in either case. So I'm just looking through electrical fixtures and lighting. And if I have multiple rules, I'm anding them, or you can do an or, you can apply a logic. We only have one rule. We have all selected, which means all of these, all the electrical fixtures and lighting fixtures and devices, all of these in the comments section contains the word enlarged. So these are all the if statements. If all the selected lighting devices, fixtures, and electrical fixtures, if the comments field, the comments parameter contains the word enlarged, then that is selected as part of this filter. So that's how I select what is filtered. And so I'm going to add that enlarged filter to this view. So I'm saying these are the filters I want in this view. Now, what happens to that? First of all, you can enable and disable a filter very easily with that if you just want to turn it on and off. But what do I want to happen with these ones that says enlarged? Do I want the visibility to be on or off? I can make them halftone. I can override the line type and patterns. I can make them colored. I can make them dashed, whatever. I just want to turn them off. So enlarged, off. That receptacle right there just turned off because it has the enlarged flag on it. So I just need to go through each of these and include enlarged. Now, you may think that's cumbersome to do. We only have to do it once and it's done. And we can also, you can use some selection tools to surround them. So I can hit all of these here. If I happen to select too much, I can filter out and just pick the electrical fixtures. But say these electrical fixtures, I can hit them all at once. Go over to comments, and now I can use the drop down. So it's really not that hard to do. But I'm doing it in this view so I can watch them disappear. And let's go ahead and do it with, let's go ahead, and what's happening is I'm picking my linked Revit model. So I can, because it's pinned, I can say don't select pinned elements over here. Now I can easily select all this stuff. Now I was careful not to pick the load center because it is an electrical fixture, but I want it to show up in both views. So I'm not going to flag it. I'm not going to include the enlarged flag. So let's go into filter. Oh, I have equipment and fixtures. So let's go ahead and comment enlarged. Now in my lighting plan, I may go through and also make this only in the enlarged view. So that's for the lighting plan. I'm not going to worry about that right now, but the rest of these, I can hit the enlarged button and make these all disappear in this view. And same with these two guys. Comments enlarged. There we go, and we left this in. So now they only show up in the enlarged plan. It didn't affect those at all. And they don't show up here. So that's as far as we're going to go on this second floor power plan.